We are in the second of the 6 systems composing the Paleozoic, the Ordovician, which lasts from minus 488 million years to minus 443 million years. This new period begins following the Cambrian extinction, probably due to an asteroid impact. At the beginning of this period, life existed only in the sea, a continental and shallow sea. The animal world was dominated by trilobites and brachiopods, which had a great evolutionary success in the Paleozoic. On land, it is nothingness. Oxygen is rare. Neither plants nor animals can develop. The supercontinent Gondwana includes all the continents of the southern hemisphere and is surrounded by the ocean Panthalassa, in which all living species are swarming. More than 490 million years ago, before the Ordovician period, the atmosphere was heavily filled with CO2, which induced a greenhouse effect, and consequently, very high temperatures. The oceans reached up to 45 degrees Celsius, or more than 113 degrees Fahrenheit. The photosynthesis reaction of the first living beings slowly pumped this CO2 out of the atmosphere. The seas cooled, which led to even more biodiversity. The Ordovician is more than favorable for the proliferation of life and evolutionary radiation. The number of genus and families almost quadrupled compared to the Cambrian. The species that dominates is that of trilobites. These marine arthropods can measure between 1 millimeter and 70 centimeters in length, the majority being between 2 and 7 centimeters, or almost 3 inches. This group is hyper-diversified, since it is not less than 18,750 species that are represented. The trilobites have a very specific anatomy. They are formed of 2 lateral lobes surrounding a median lobe, the longitudinal trilobation, and a head called cephalon. They have a solid exoskeleton. It is thanks to the molt that fossils of exoskeleton could be found thereafter. The main organs of the digestive system are located in the rachis. As in other arthropods, their muscles are striated, and the nervous system consists of a cerebral ganglion and an optic nerve, leading to the faceted eye. A voluminous dorsal vessel, made up of hearts, pumps colorless blood. Trilobites live only in water, with a great preference for the substrates constituting the bottoms of seas, oceans, and lakes. They feed mainly on invertebrates such as worms. Thanks to their legs covered with spines, the trilobites catch the worm and tear it before bringing it to its mouth. The trilobites laid eggs of a size of 200 micrometers. The genital pores are located at the back of their head. Brachiopods are lophotrochozoan animals, a major group of the mollusk class, the protostomians, which live exclusively underwater. Their shell has 2 valves with a particular symmetry, since instead of being positioned on the right and left, they are located ventrally. The peduncular valve and the larger, and dorsally, the brachial valve the smaller. The shell of a brachiopod is distinguished by the existence of a spiral brachial skeleton that lends itself to be the support of the lophophore, an organ near the mouth that contributes to the feeding of the animal. From the lophore, tiny filaments trap plankton and deposit it in the mouth. Brachiopods live permanently attached to their substrate. While everything is going well on Earth and life is proliferating, at the end of the Milky Way, a few thousand light years from Earth, a star at the end of its evolution explodes into a supernova. Intense radiation energy emerges from its poles and releases a remarkable quantity of gamma rays. In 10 seconds, the explosion of gamma rays produces more energy than 1,000 suns. At a speed of 300,000 kilometers per second, or 170,000 miles per second, these rays cross the universe and reach the Earth. They first pass through the atmosphere and annihilate the air molecules. Only 10 seconds after the explosion, it is the return to calm, and yet the future of each species is now threatened. In the middle of the day, a second star shines next to the sun. The supernova shines and will shine for a few more months before disappearing. Almost a third of the ozone layer has been destroyed by gamma rays. The ultraviolet rays of the sun can now pass through the atmosphere. The Earth becomes a furnace, and the 50 times more intense sunlight is literally intolerable. The organic matter that plankton feeds on is totally burned by the sun. The plankton eaters are in turn deprived of food. The trilobite larvae that incubate in the surface waters do not survive the intensity of the solar rays. Their reproductive cycle is strongly compromised, and the adults become the prey of predators. The corals are decimated in just a few weeks. The whole food chain is disrupted. In the tropics, the rays are even more violent and cause the death of coral reefs. The DNA of all plant and animal species is damaged. The trilobites become scarce in their turn, and it is the beginning of the hunger for the big predators. Orthoceras and eurypteroids then fight a merciless war. Orthoceras are cephalopods with univalve shells that can measure from a few centimeters to 11 meters long, or from a few inches to 36 feet. They are the main predators of the Paleozoic era. The eurypterids are chelocephate. Eurypterids are the largest arthropods to have existed on Earth. In the atmosphere, nitrogen and oxygen molecules are turned upside down and transformed into a harmful gas, nitrogen dioxide. This newly formed gas will spread in a layer, allowing harmful ultraviolet rays to pass through, but not the heat, which is, however, an elemental element for the maintenance of life. Temperatures fall, and a period of glaciation begins. The ocean, teeming with life, degenerates into an ocean of misery. The eggs laid in the cold no longer develop. Fortunately, since ultraviolet rays do not reach the depths, some species, such as eurypterids and nautiloids, take refuge in the shallows of the oceans in order to survive. More than 500 years later, the report is alarming. All forms of life on Earth are threatened, and a third of the fauna has already disappeared. 150,000 years later, the Ordovician fauna is dying slowly. The cold is intense. The planet is cooling down year after year. Famine is rampant, and predators are becoming scavengers. The glaciers suck the water out of the oceans until the water level drops by 50 meters, or more than 165 feet. The shallows dry up, and thousands of animals are left for dead. Nevertheless, some species manage to adapt to this new climate and these new living conditions, like the astrapis. With a small size not exceeding 15 centimeters or 6 inches, the astrapus is one of the few primitive fish species. It has a primitive backbone and a bony carapace that protects the spine. This animal is the ancestor of all vertebrates existing today, from birds to reptiles, through mammals and humans. The astrapus does not give the impression of being robust at first sight. It feeds on microbes and algae, and is a prey and not a predator. However, it will adapt and flourish during this period of glaciation. It adapts better to the cold than any other aquatic species and will follow the retreating ocean. Compared to carnivorous species that feed only on a particular prey, and therefore cannot survive when that prey disappears, the astrapus does not make the difficulty. It feeds on everything it finds. Very quickly, new varieties of fish arrive with new evolutions. The arteries and muscles will form the first gill, which will facilitate the sorting and absorption of food, and will later give the base of the orthoceras in the food chain. The cold persists and gigantic icebergs form under the surface, destroying everything in their path. The aquatic habitats are reduced. "500,000 years after the gamma ray burst, 2/3 of the animal world disappeared. Temperatures on the planet are finally starting to rise thanks to the gradual influx of CO2 from volcanoes. Little by little, the glaciers are melting. This new climate change upsets the species and pushes them to adapt again. 70% of the species disappear forever from the surface of the Earth following this extinction. During the millions of years that follow, the orthoceras is weaker than ever, but still present. It is smaller, weakened, and becomes an easy prey. On the contrary, the Eurypterid becomes a ferocious predator. With the decrease of the water level, the sea scorpion saw developing its lungs, allowing its blood to circulate through the tissues and to recover oxygen. It is now ready to venture onto the shore. It becomes as big as a crocodile and a feared predator. Acanthodians, fish cousins of astrapus, are also subject to extraordinary evolutions. They now have jaws that allow them to cut flesh from the carcass. They who used to feed on microbes and algae climb the ladder in the food chain. The planet is in remission, but the toll is heavy. It is gradually regaining its tropical climate and is seeing its water levels rise and aquatic habitats being recreated. All the fish we know today come from species that appeared at this time. But the Earth is about to undergo another cataclysm. During the Devonian period, the Panthalassa Ocean still covers a large part of the Earth. The supercontinent, Proto-Gondwana, is located in the south and is slowly moving northwards, while many islands and archipelagos are spread out on the equator. The climate is warm, between 25 and 30 degrees Celsius, or almost 86 degrees Fahrenheit. More than 200 million years have passed in tranquility, and in the vast ocean, animal life proliferates with abundance. Coral reefs cover millions of square meters. These ecosystems are populated by sponges, trilobites, mollusks, nautiloids, and brachiopods. Fish are also present and have evolved a lot. Placoderms impose themselves as the new species of fish on the front. Equipped with bony plates covering the front part of their body, they are now equipped with fins. A new space of displacement is offered to them. They can take height and escape the terrible scorpions of the seas. They are the first pelagic fish. Another new characteristic makes their strength, their jaw which articulates. From now on, they are able to tear and bite. Armed and harmful, placoderms are outstanding predators that hunt everything within their reach. From then on, aquatic vertebrates were divided into two major classes: fish with radiating fins, which still make up 50% of vertebrates today, and fish with fleshy fins, equipped with lungs, allowing them to breathe in the open air, and which would evolve much later into tetrapods. On land, vegetation evolved and became luxuriant thanks to a warm and humid climate. Ferns and lycopods abound, and tiny insects proliferate. In the absence of herbivorous species to limit the spread, vegetation abounds, and the first forests appear. The first broad-leafed plants appear, and by the same token, the photosynthesis reactions that contribute to enrich the atmosphere with oxygen. The first proto-legs develop on some fish, because in order to be protected from predators, they are led to take refuge in the waters of rivers, lagoons, or mangroves. In these shallow waters, roots and vegetation are intertwined, creating a cramped space in which the fish will have to use its fins differently. It clings, spreads, flattens, so much so that they are no longer useful for swimming, and evolve in a few million years into proto-legs. At the end of the Devonian, some fish with fleshy fins evolved into tetrapodomorphs, like the tiktaalik. It is an intermediate species between the fish and the tetrapod. It can reach up to 2 meters long and sees its body and its head flattened in order to keep the body in water, but to be able to take out the head to breathe, even if it can also breathe underwater. It is physically similar to the crocodiles of today. It is only 30 million years later that the first aquatic tetrapods were born, such as Ichthyostega, which will be one of the most important transitional links between marine vertebrates and exclusively terrestrial vertebrates. The first tetrapod to move on land arrived sometime later. It is Acanthostega. During several million years, it will make journeys between the aquatic environment and the land until becoming completely terrestrial. Scorpions and spiders also join these tetrapods outside the water. The Devonian extinction will extend over some 3 million years following a series of events. It all starts under present-day Siberia, in the heart of the Earth, where an ocean of magma is bubbling. A giant plume, an upwelling of hot rocks from the Earth's mantle, is being formed. It eventually breaks away from the magma, pierces the Earth's crust, and explodes. Extremely hot gases are projected onto the surface of the Earth. The water begins to boil, and underwater earthquakes annihilate the reefs. The colossal eruptions reach areas of 60 square kilometers with an energy equivalent to 1,000 nuclear bombs. In the surroundings, millions of fish die under the heat. The giant plume continues its conquest of the Earth. The prosperous animal kingdom that reigned is annihilated. The activity of the tectonic plates intensifies. The ocean floor cracks, and new oceanic crust and underwater volcanoes are formed. Another consequence of the plume is that it poisons the ocean, because when the molten lava comes into contact with the seawater, it releases many metals such as iron, magnesium, gold, and silver, toxic substances. Everything leads us to believe that the apocalypse is near. The Earth will never be the same again. "8,000 years have passed. The ocean continues its battle for survival without respite, but it is now the Earth's atmosphere that is under attack. Thousands of tons of toxic gases, such as carbon dioxide, are slowly released into the air, loading it with greenhouse gases. The temperature rises. The ocean currents, which were previously assured by a redistribution of heat, stop, and the world freezes. The water of the oceans reaches 32 degrees Celsius or 90 degrees Fahrenheit. The aquatic environment dies. The trilobites do not survive. 250,000 years later, the giant plume continues to trigger volcanic eruptions. The vegetation takes advantage of these favorable conditions for its proliferation to develop in abundance. The planet becomes a paradise for plants that need sunlight, carbon dioxide, and water. Vegetation flourishes, and many leaves fall to the ground. This accumulation of plants rots over the years and forms the first layer of humus on the planet, like a rich and deep soil. The darker part of the story is that when it rains, the soil is washed into the ocean. The algae absorb the nutrients and grow unchecked. The seas become saturated with plants. North of the equator, the ocean is nothing but bacterial sludge and looks like a cemetery. A few Dunkleosteus, large arthrodire placoderms, fight against starvation, but their appetite and the lack of food forces them to cannibalism. Even if the animal kingdom seems to be dying out, some of the more resistant species are developing astonishing ways to adapt to their new world. This is the case of the Moderpesis in Australia. This small fish that fits in one hand is able to crush a shell with its teeth, but its strength lies elsewhere. This viviparous fish protects its young in its abdomen, a fundamental characteristic for its survival at one of the worst times of the planet. 750,000 years after the giant plume, eruptions are now hitting the Earth. A gigantic volcano is preparing. It is in present-day Western China that the eruption takes place. Lava geysers reaching hundreds of meters in height gush out. A cloud of ash is formed on the whole sky, which takes a reddish-orange color. A black veil hides the light. While the Earth had been functioning as a huge greenhouse for several thousand years, the volcanic gases that now mask the sun's rays will plunge the planet into a volcanic winter. The temperature of the oceans will drop from 32 to 21 degrees Celsius, or from 90 degrees Fahrenheit to 70 degrees Fahrenheit. Fish eggs and plankton are eradicated. In Greenland River, tiktaaliks survive, but the first snowfall will surprise them. The Earth, which was tropical, cools down, and the frozen waters will bring the tiktaaliks to their loss. They die out little by little, until they disappear completely. The volcanic winter ends 1.5 million years after the beginning of the plume. The plume is finally extinguished. 70% of the species have perished. The ocean is now a gigantic empty bathtub. The reefs that once covered 5 million square kilometers are reduced to a few thousand. The Earth is devastated, emptied. It becomes a hostile world. Microscopic bacteria and algae invade the ocean floor, so much so that one would think one was back in the Precambrian era. The trees still present will produce oxygen and contribute to the rebirth of the Earth. Temperatures stabilize, and life diversifies again, especially in the tides. During the Permian, the two continents, Laurasia and Gondwana, merged to form a new supercontinent, Pangea. This movement of the continents modified the climate, giving the Earth a completely different shape and allowing new life to develop. Immense arid deserts and mountain ranges cover the surface of the planet. The water level decreased considerably, and a new ocean was formed, the Tethys, from east to west of Pangea. Temperatures on the surface of the Earth vary between 0 degrees Celsius and 40 degrees Celsius, or range between 32 degrees Fahrenheit and 104 degrees Fahrenheit in a single day. The forms of life are diverse. We find plants, reptiles, amphibians. At the aquatic level, mollusks, echinoderms, and brachiopods develop. Animals adapt to these new climatic conditions and develop ways to regulate their body temperature. Dimetrodon and Edaphosaurus, mammalian reptiles, develop dorsal veils and thermoregulatory power that allowed them to vary their body temperature by absorbing or evacuating heat. Others will mutate and evolve, like the therapsids, by developing a fur as a means of protection. Some species become bipedal, and flying animals made their appearance. Molten rock that was previously buried under the Earth's crust bursts out into the open. The ground splits in two for about 30 kilometers, that is to say 18 miles. It is a real tidal wave of liquid fire. A lava flow quickly covers the equivalent of the surface of Florida in only 48 hours, and it doesn't stop there. While most volcanoes explode and stop between their periods of activity, the eruption of the Siberian Traps is manifested by a basaltic outpouring that continued over the years. Pangea is soon completely won by the anger of the volcano, installing a dangerous natural imbalance. Life near the traps is instantly decimated. The surviving animals try to flee far from Siberia, but the consequences of this catastrophic event will not let them rest. 10 years after the eruption, volcanic gases that have accumulated in the atmosphere are causing climate changes. Carbon dioxide and sulfur dissipate from the Earth's crust. Sunlight becomes obscured, and the trapped heat results in decades of unstable weather patterns. The alternation of cooling and warming phases makes the balance of life impossible. All areas of the Earth are affected. In South Africa, 24,000 kilometers, or 15,000 miles from Siberia, survivors are beginning to struggle to breathe. The temperature rises a few degrees and the oxygen level drops. The respiratory system of listosaurs or gorgonopsians cannot withstand the lack of oxygen. Predators and prey share the same battle. The Thrinaxodon, a small animal that one would have thought easily defeated, seems to be favored by evolution. It shows a great resistance to heat because of its small size and faces air pollution thanks to the bony structure of its face, which allows it to breathe and chew at the same time. Its community life also allowed it to enjoy a solidarity during this cataclysm and to lighten the burdens such as feeding or defending itself. 25 years pass after the eruption, and the molten rock continues to spread. When it comes into contact with the air, it congeals into a black mountain on which no life is possible. the animals that live in these regions must leave. Some die of hunger. Half of the Gorgonopsians are decimated in northern Asia, as a new catastrophe is brewing. Our distant ancestor, the Thernaxodon, manages to find shelter. 50 years after the beginning of the cataclysm, the volcanic eruptions remain. The Siberian traps are located on a coal reserve. The methane it contains is suddenly released, and much more powerful than carbon dioxide, it contributes to the greenhouse effect. The warming accelerates. The plants, which are the base of the food chain, perish under the heat, and famine sets in. Large herbivores like dictodons are not spared. The Thernaxodon becomes a scavenger and feeds on remains, insects, and amphibians. 10,000 years after the eruption, life on Earth is on the verge of total extinction. The floods linked to the spring monsoon carry millions of tons of dead plants to the sea, transforming it into a huge landfill that putrefies under the effect of the heat. Oxygen in the ocean becomes scarce, and the rocks become black. The ocean floor is covered with corpses. Only the bacteria survive. The majority of the species that dominated the marine ecosystem disappeared. By emptying itself of its oxygen, the ocean also survived the cataclysm, which is crucial for the subsequent emergence of man. The Permian mass extinction is the most devastating in the history of the Earth. 95% of all life forms disappear, including 70% of terrestrial species, such as vertebrates, plants and insects, and 95% of marine species. 89 genera of reptiles, among the 90 existing, do not survive. This is a colossal regression for the history of evolution. The Permian extinction ends the Paleozoic era. We are now in the Mesozoic era, also called Age of Reptiles, whose first period is the Triassic. The Triassic period begins after the Great Permian extinction, which considerably reduced biodiversity, since 95% of marine and terrestrial life disappeared forever. The Earth is characterized by their fossilized trunks, and lepidodendrons among others. It will take only a few thousand years for the flora to be abundant again, and for the vegetation to green up on Pangea. On the fauna side, the disappearance of the vast majority of species has left a large number of ecological niches free. The surviving species are brought to move. The animals will conquer this new environment. In the seas and oceans, the previous extinction had spared no one, since 95% of the species in place were led to disappear. Life has nevertheless resumed its course, and the oceans are gradually repopulated with new varieties of modern corals, mollusks, and many species of fish. Within a few thousand years, life was once again teeming under the waters, but it would never be as abundant as during the Paleozoic. Chondrichthyans, distant cousins of sharks, appear. These fish are characterized by paired fins, scales, and a skeleton composed of cartilage and not bone. Hybodonts are also found in the marine environment. They evolved clearly throughout the Triassic period. At first they were small, about 20 to 30 centimeters or 12 inches, and fed on small prey. A few million years later, they adapted to the salinity of the coastline and diversified, reaching sizes of up to 3 meters long, or more than 9 feet. They developed teeth that allowed them to tear and also to crush. They then occupied the top rank of the oceanic food chain at that time, before the arrival of marine reptiles. It was during the Triassic period that marine reptiles developed and flocked to marine and oceanic waters. Several families of marine reptiles arose, but some did not last, such as placodonts, marine reptiles that fed on hard prey and crustaceans, or thalattosaurians, reptiles with long paddle-like tails and slender bodies. The marine reptiles that made a permanent home on Earth were the ichthyosaurs, or lizardfish. They are marine vertebrates that measure between 1 and 10 meters in length, that is to say, between 3 and 32 feet. They moved in the water relatively easily and quickly, thanks to their large fins, and later they will also opt for a movement in successive jumps on the surface of the water, like the present dolphins. On land, the last survivors of the Permian extinction are the most widespread. The Rauisuchians, archosauromorphic reptiles, are at the top of the food chain. The most basal of the group would give rise to the archosaurs and then the pterosaurs, almost 3 feet long. The largest and most numerous are the Plateosaurus, herbivorous dinosaurs measuring up to 10 meters long, or more than 30 feet long. Mammals managed to survive the Triassic period without difficulty. The most numerous are the therapsids, the diconodonts, and the Lysowisia. This animal, weighing between 5 and 6 tons, had a size close to that of Asian elephants. It is the largest of its environment. Let's remember, during the Permian extinction, the Siberian traps let out lava and toxic gases on the Earth for 1 million years. Now the surface of the planet is calm, and the hostile desert that the Siberian traps left behind is once again welcoming and lush to life. But deep in its bowels, the Earth still boils. The forces that brought Pangea together a few million years ago are breaking it apart. The gradual displacement of the continents is causing the magma that makes up the mantle of the Earth's crust to flow, and when these forces break up Pangea, lava will gush out in considerable quantities. This is the beginning of a new mass extinction. For several weeks, a rumbling has been heard and felt. In a fraction of a second, Pangea is torn apart. Geysers of burning steam come out of the bowels of the Earth and shoot up to more than 1,500 meters of altitude, or 5,000 feet of altitude. The gigantic eruptions of burning steam trigger an intense volcanic event a week later that leads to the division of Pangea and the formation of the Atlantic Ocean basin. The volcanic eruption is triggered, lava gushes out through land cracks, and the magma spreads like a gigantic fire wave. The cracks can reach up to several 20 kilometers or miles in length. They are literally waves of flame that run until they reach animals and vegetation, swallowing everything in their path. Nothing has ever been comparatively so violent since the birth of humanity. The herbivores rush to flee, but the quills on their backs protecting them. For months the lava flows. The animals flee, but have nowhere to go. Faced with this critical situation, some are better equipped than others to adapt to change. This is the case of the Staurikosaurus, one of the very first dinosaurs. It is 50 years past during which volcanic eruptions follow one another. A layer of lava gradually covers the surface of the globe. These eruptions produce a lot of gas dissolved in the magma. When they rise to the surface, millions of tons of noxious gases are released into the atmosphere, and the carbon dioxide level increases. Temperatures rise considerably. The heat is so great that it becomes suffocating, so much so that marine animals also suffer from the heat wave. The Rutiodon, a kind of archosaur, lives in the water, but is forced to venture onto land to lay its eggs. This particularity of his species condemns him forever. Feeding itself becomes an ordeal for all of them, until they eat their offspring. A few decades later, the heat is still imposing, and now the concentration of oxygen in the air is very low. It would be impossible for modern man to breathe in such conditions. Dysmatosuchus will bear the brunt of this low oxygen concentration. Although they have never feared predators thanks to their imposing carapace, they are in a bad position this time because their respiratory and pulmonary capacities are very limited. Every movement is laborious for them, and they start to stay localized in smaller areas. The lack of oxygen also affects the reproduction because the eggs are not oxygenated enough for the embryo to develop. The births decrease, the survivors and the newborns become weaker. The population of Dysmatosuchus eventually becomes extinct, which benefits the Staurikosaurus. The latter does not have the same physical structure. Its limbs are aligned with the rest of the body, and therefore do not interfere with the internal organs. The lungs unfold fully, and it has less difficulty breathing. Staurikosaurus also has extra air pockets, like birds and dinosaurs, creating a continuous flow of oxygen through the respiratory system. This is how a bird that breathes the same air as a human will absorb 30% more oxygen. The years go by and cracks appear again and again. The surface of Pangea is dying, and a new world is slowly taking an organic matter. The ocean world is similarly impacted. The water, in turn, becomes acidic, and the plankton, the basis of the food chain, dies. Then, the fish and all the creatures that feed on them succumb in turn. Eudomorphindons go along the rivers and lakes to find food, but they will have to make do with the only corpses rotting on the ground. It is now 70,000 years since the catastrophe began, and the Earth has a new face. Many organisms have disappeared, and others are taking advantage of the situation to spread, such as bacteria. These bacteria transform the ocean into a dirty place. The sky turns yellow, and the smell of sulfur is everywhere. In this unwelcoming scenery, a living being clings to the little life it has left. It is our distant ancestor, the Megazostrodon. This small mammal has an advanced pulmonary apparatus with a membrane of muscles and tendons that separate the lungs from the rest of the organs, the diaphragm. This makes it easier for it to breathe, despite the toxicity of the air. The Megazostrodon also has a major advantage for its survival. It is one of the first animals to nurse its young. The female, therefore, only has to draw on her own resources to feed her offspring, while others have to find food for them. 250,000 years have passed since the eruption, and Pangea is unrecognizable. Fissures run through the earth on both sides, and molten rock still flows from them. The quantity of magma poured out will reach a total of about 2 million square kilometers. Desertification spreads over entire regions. In some rare regions where life remains, the Styracosaurus continues to evolve and find its place. In addition to its advanced pulmonary system, it now incubates its eggs. This body contact provides temperature regulation and protection. The new generation emerges stronger and more robust. Dinosaurs are becoming more and more numerous. It will be only 500,000 years after the beginning of the events that the eruptions stop. The shifts in the Earth's crust definitely broke up Pangea and divided distinct continents as we know them today, which favored the opening of the Atlantic Ocean. The 3/4 of the terrestrial fauna disappeared forever, affecting more particularly the herbivores, like the Desmontosuchus. Underwater, the disaster is also without appeal. The coral reefs are almost all destroyed. It will take 600,000 years for the Triassic extinction to end. It is still as hot as ever. The air is barely breathable. The carbon dioxide level is at its highest. But our world as we know it today was born. The Styracosaurus has adapted to the worst possible conditions, and now the planet is his and his kind. They multiply and invade the land, creating new habitats and new species. Alongside these giant lizards, we find the ancestor of the current mammals, the Megazostrodon. They will evolve during the next thousands of years. We are now in the Cretaceous period. Seen from the sky, the Earth appears very familiar to what we know today. The fragmentation of Pangea draws the features of our current continents. The planet has no ice caps, so the climate is always warm. The oceans are 200 meters higher than today's level, more than 650 feet higher. Ferns, conifers, and flowering plants dress the landscape. Reptiles still dominate the aquatic environment, although one of the largest groups, the ichthyosaur, disappeared for reasons that are still quite mysterious. In the air, creatures reach impressive sizes, like the Quetzalcoatlus, with its 15 meters or 50 feet wingspan that fly majestically. The pterosaur has to be careful. It is less and less present on this land of giants. In fact, on dry land, the gigantic dinosaurs are the group of animals that has dominated and reigned supreme for several million years on all continents. Well established, they evolved and diversified, and new species emerged, such as the Tyrannosaurus, the famous T-Rex. With a long, powerful tail and a massive skull, it measures more than 13 meters or 40 feet and can weigh up to 8 tons. It is the largest carnivore that has ever existed on Earth, and by far the largest of its time. Alongside the dinosaurs, the mammals still have a place. Smaller in size, they are no bigger than a mouse, while the smallest dinosaur measures 1.20 meters, or 4 feet. 2 million species of animals lived together at that time. A few 100,000 years before the famous cataclysm, an exceptional volcanism took place at the level of present-day India. Its name? The Traps of Deccan. Over more than 1 million years, lava flows fall on the surface, covering more than 2 million cubic kilometers, reaching in some places more than 800 kilometers or 500 miles long. These basaltic flows are accompanied by emissions into the atmosphere of large quantities of carbon dioxide and sulfur dioxide, two gases that can modify the climate. These emissions of sulfur, after conversion to sulfate aerosols, would have induced, 65 million years ago, brief episodes of global cooling, while CO2 would have caused a warming of 3 degrees Celsius or 37 degrees Fahrenheit in the longer term, most likely contributing to the most famous biodiversity crisis in the history of the Earth that will follow. A few million kilometers from Earth, in the asteroid belt between the orbits of Mars and Jupiter, one of the celestial objects goes off course and heads for Earth. Launched at several kilometers or miles per second, the asteroid, up to 10 kilometers or miles long, lands on the Earth like a bomb and forms a crater 50 kilometers or 30 miles deep in the Yucatan Peninsula in Mexico. The energy released by the asteroid is equivalent to 100 million megatons. In less time than it takes to say it, the water within a radius of 60 kilometers or 37 miles turns into vapor, suddenly killing millions of lives. Animals near the impact bridge do not have time to feel the shock, as they are hit at a speed far faster than their reaction time. The vaporized rocks form a hot cloud and quickly move towards the ocean. This is the shock wave. Everything in its path is evaporated. Part of the Earth itself is transformed into vapor over the entire continental United States. Even the mighty Tyrannosaurus will not withstand the shock wave. The only survivors are those who manage to take shelter in caves. Fires break out. North America is like a giant inferno. Prey or predators, parents or children, no one is spared. Our distant ancestor, the Purgatorius, a mammal, stays in his burrow. Its small size allows it to find shelter, to take cover, and to protect the survival of its species. 10 minutes after the impact, the shock wave has released all its energy. But the consequences start to be felt. The Earth shakes. Rumblings are heard. It is an earthquake of very strong causes landslides. The tremors and aftershocks lasted several days. The asteroid continues to cause destructive phenomena. Less than an hour after the impact, a giant tsunami is heading towards the coast at a speed of 1,000 kilometers per hour, or 620 miles per hour, the size of a mountain range. On the coast, animals see the ocean receding, then a line on the horizon growing closer and closer. The tsunami hits the land, catching trees, animals, and debris, and scattering them across the landscape. This wave, which measures several hundred meters in amplitude, or almost 1,500 feet high, sweeps the planet, not sparing aquatic animals either. The mosasaur, which can measure up to 17 meters or 55 feet, is caught by the current and pushed back to the shore, where it will await certain death. The wave submerges the lowlands, digging holes more than 300 meters or 1,000 feet deep, after which it retreats with such force that it carves a new landscape. A few hours later, the ocean calms down and the survivors emerge from the rubble to contemplate the extent of the damage. But before they could come to their senses, another consequence of the impact hit. When the asteroid hit the Earth and dug the crater, millions of tons of rock were propelled into space. They are now falling back on the planet, forming the largest meteor shower of all time. Pieces of the Earth's crust are crossing the atmosphere again for several hours. The planet is in flames. All creatures are harmed. The temperature climbs in a few hours, and the heat becomes unbearable to the point that in some places the rivers start to boil. The Earth is unrecognizable, and yet some specimens resist this apocalypse. The Purgatorius takes refuge underground, while on the surface, the dinosaur world collapses. It waits for calm to return, and organizes itself by rationing its food. In the Yucatan Peninsula, the crater is a caldera. Mountains rose to 5,000 meters above sea level, more than 16,000 feet high. The Devonian is situated between minus 419 and minus 358 million years. This is the time of the first forests. Yes, you heard me right, the first forests. But how can you go from lichen to a whole wood? The vegetation cover was formed little by little, of course. The Devonian represents millions of years. Every day that passes is a new promise for terrestrial life. But the most significant changes took place here and now. This is where it all began. During this period, especially in the Upper Devonian, our planet experienced an explosion of plant and animal life. If the Cambrian left an indelible mark on the ocean, the Devonian is without a doubt the one that will favor the enrichment and the development of the terrestrial soil. After our little escapade in the Silurian, let's go a handful of millions of years later, to the very beginning of the Devonian, to better understand these changes, these evolutions, and finally, the birth of life on Earth. Here, the temperature at the ground oscillates around 28 degrees Celsius, or 82 degrees Fahrenheit. The oxygen level is close to 15%. The air is humid, and a light wind can be felt. Can you feel that little breeze on your skin? It is here in these conditions that the first forests will be born. You have to imagine that the surface of the Earth has changed somewhat since its creation. Mountain ranges have emerged, like the Appalachian Mountains, and rivers have made their beds. The panorama is extraordinary, but life is still in its infancy. For the moment, as you can see, we are still on a small vegetation cover. We are far from the spectacle offered by our current forests. Today, forests are made up of several layers, with the presence of humus, litter, small plants, shrubs and bushes, and finally, large trees whose tops reach several meters high. Here, the highest point is about 50 centimeters or 20 inches. During the first half of the Devonian period, the flora was limited to the herbaceous stratum, with low plants generally located near waterways, such as Rhynia or Asteroxylon. The Asteroxylon is the larger of the two. It is covered with small scale-like leaves without veins. This plant species likes dry soils rich in organic matter. It is one of the first plants to form litter and thus enrich the soil with organic matter. The majority of the other species measure about 10 centimeters or 4 inches maximum. Then, a more varied vegetation allowed to enrich the soils, which in turn allowed the growth of new plants. It is a virtuous cycle that is established. 30 million years. 30 million years were necessary for the vegetation to evolve more clearly. The most striking phenomenon of this period is the appearance of the shrub and tree layer. We are going to make a new jump in time to realize these transformations. Here we are now, 30 million years later, at the dawn of a primitive forest. It now has some similarities to our current forests. Can you determine which ones? Indeed, this one functions through an ecosystem with floors with strata. There is the herbaceous stratum that we already know at ground level, but also the shrub layer, and finally, the highest, the tree layer. You see, tall trees such as those that are rising before our eyes 30 million years ago, they did not exist. There are 4 major groups of arborescent plants in the Devonian. The lycophytes, about 3 meters or 10 feet, the cladoxylales, about 8 meters or 26 feet, the aneurophytales, about 1 meter or 3 feet, and finally, the archaeopteridales, up to 25 meters or 82 feet. Let's start by exploring the first layer of vegetation, the one in front of us, just under our feet. If it is less high, it is not easier to cross. Roots and stems intermingle and become a real vegetal mishmash. At the edge of the water, we can see Rhynia. They are part of the first terrestrial plants. At the end of their branching stems, there are small yellowish olives. These are not the fruits of the plants, but sporangia. Be careful when crossing the crossroads of low plants. You can easily get stuck. Their stems and bark are like Velcro. Sporangia plants like Cooksonia are very similar to the Rhynia you had the opportunity to observe a little earlier. They appeared a little earlier during the Silurian and continue to evolve. All the conditions are met for them to prosper. Under them, lycopods, Leclercia, moss plants in a way, cover the ground. Let's leave this first stratum and go to the second level of the forest with the shrubs. Next to you, these are Relimia bushes. It is one of the first extraordinary phenomena of this so particular era. No bush, no shrub had until then plunged its roots in the bowels of the earth. A little further, while advancing until the edge of the forest, you can see Tetraxylopterus. All along the trunk are branches with stems of all sizes intertwined. It does not really have leaves as we can imagine from the knowledge we have of our current forests, but rather branched and flattened stems. If from afar the vegetation can resemble ours up close, there is no mistaking it. Many points differentiate them. They are far from being as high as in our forests on the one hand, and they rarely have leaves with many veins, as we are used to see. Some trees look like primitive weeping willows, others like the beginning of a cactus, thin and long. We realize how much these 30 million years have allowed to diversify and enrich the terrestrial vegetation. Nothing will ever be the same again. The richness of the soil favors a luxuriant and varied vegetation. All this constitutes a new ecosystem, a terrestrial ecosystem this time. We can see here one of the giants of this time, the Eospermatopterus. It measures approximately 8 meters in height. Remember that a few thousand years ago, the vegetation did not exceed 50 centimeters. 8 meters high, the change is radical. This is a specimen that occupies the tree stratum. Can you recognize the Eospermatopterus from here? It is the one that you can see with a gray-brown trunk in the distance. It looks like a palm tree. The trunk is long, straight, and thin. At the top, several branches form a ball. When one of them withers, it gives way, then forms the trunk. If you go a little deeper into the forest, you will meet the biggest of them all. It is an Archaeopteryx. It is almost 25 meters or 82 feet high. It could be similar to our current fir trees for its shape, since the branches start only on the upper part, leaving the rest of the trunk bare, and that the leafy part forms a triangle. One of the great characteristics of this tree, besides its size, is its leaves. They resemble our ferns in their configuration, and they can measure up to 1 meter or 3 feet. It also has a well-developed root system that may have contributed to the formation of deep soil. Underneath this behemoth, you can see a small plant. Is it a nice fern specimen? Well, no, not yet. It is a very young Archaeopteryx. The fern is a plant that is also found in the 21st century, and yet already existed millions of years ago. You will be able to see it soon. A little patience. If the fern appears in the Devonian, like Osmundaceae or Hymenophyllaceae, it develops more widely in the Carboniferous. If plants could pass on their knowledge from generation to generation, they would have incredible stories to tell and immeasurable knowledge to offer us. But we don't have time for poetry. We must continue our study of the primeval forest. A little further on, you can see horsetails. These plants belong to the genus Sphenophyte. Another genus develops widely, that of lycophytes, which includes lycopods and selaginellas. The Devonian is a very enriching period in terms of vegetation. The latter diversifies and becomes more and more abundant. It also brings new elements that will be integrated into a new ecosystem. Leaves, roots, arborescence, wood, and bast appear. All these new elements can become a habitat or a new nutritive source for the species to come. If the plant biomass is still quite minimal and fragile, this plant cover, already well supplied and increasingly thick, allows some insects to see the day and to establish themselves on the ground. To see them, you will have to be patient and sharpen your sense of observation. Some of them are rather shy and shy nature, while others blend perfectly into the scenery. One of the oldest known springtails is this one, Rhyniella precursor. It is only 1 to 2 millimeters long. It is therefore very difficult to observe with the naked eye. Despite its small size, it has its place in this new nature and plays an essential role. It belongs to the scavengers. It feeds on decomposing matter and thus allows to clean nature. The cycle of life settles down slowly in this incredible landscape which the earth dresses. Here is another insect that lived for a long time in the Devonian period. But about it, great interrogations still reign in the spirits of the scientists. I propose here the 2 plausible versions of the famous Rhyniognatha. For a long time, we considered it to be part of the group of flying insects. Its mouth parts were indeed reminiscent of those of a mayfly, a winged aquatic insect. Here is what our Rhyniognatha would look like if these first investigations were correct. Some details suggest an animal of the order of myriapods, thus millipedes, and in particular, the Scutigiromorph millipede. It would then look more like this. Going back so far in time is not an easy thing. We have much more knowledge today than we did a few hundred years ago, and technology provides many answers. Nevertheless, such distant periods still conceal many mysteries, including the morphology of our millipede. On the other hand, we know a little more about the next insect, the Leverholmia. It measured no more than 10 centimeters or 32 inches and was recognizable thanks to its 5 pairs of walking legs. If you get a little closer, you will see that they are covered with hairs or bristles. The diet of this insect is quite varied. It feeds on spores, fragments of macerated plants or mushrooms. It is therefore a detritovirous insect. The plant litter is the environment that it favors to find what it needs to survive. It is notably thanks to this type of insect that the formation and enrichment of humus is possible. If the vegetation and the development of insects constitutes a new ecosystem on our planet, the Devonian embodies many other novelties, in particular, the birth of an animal of a new kind, the Ichthyostega, is very particular. It is a tetrapod with fish characters. It seems to be the missing link that allows us to understand one of the fundamental elements of the evolution and the arrival of certain animals on the Earth. If it is undoubtedly not alone in the key element that would fully solve the mystery, it constitutes a pivotal group, that of the vertebrates that tried to move from an aquatic to a terrestrial environment. The Ichthyostega is a species of the stegocephalic group. It has a singular mobility, since it is recognized for its primitive members, as you can realize by observing this specimen, which comprises 3 beginnings of articulations which could be similar to the hip, the knee, and the ankle. What is rather surprising, it is that it also preserves characteristics of fish. We note the presence of caudal fin, but also scales on the tail and the ventral face. As an adult, it develops internal gills. It seems to live mainly as a fish, but it can also spend some time on land. Others, like this one, appear to be the perfect cross between a fish and a reptile, or crocodilian land animal. Look at this Tiktaalik. It's a fish that looks like an alligator, don't you think? If the trunk and the tail seem to suggest a fish, the line of the head is largely similar to that of the alligator. The fins are clearly visible on the flanks, but they are a sort of cross between real fins and legs. Its articulated bony skeleton and its famous legs allow it to move over short distances in the lagoons. The Elpistosteg bears some similarities with the Tiktaalik. The scales, the short head, the elongated and thin trunk, the caudal part as well as the anal fin are also present in it. The Panderichthys, as for him, if he seems to have some common characteristics with the tetrapods, looks much more like a prehistoric fish. It is part of those groups with a form anatomically transitional of the tetrapods. This one measures about 90 centimeters or 35 inches, but the biggest ones can reach 130 centimeters or 50 inches. Under its catfish appearance, it preserves an internal skeleton with pectoral and pelvic fins. It also has chiridian limbs. That is to say, that it is made up of articulated locomotive appendages which enable it to swim, but also to walk. It is on this improbable meeting that we will close the chapter of the Devonian. An ice cap appeared at the end of this period at the South Pole. Other changes are coming. It's time to continue our journey and get back on the road to land in the Carboniferous. Did you feel the air getting cooler before we left? The global temperature has dropped a lot due to decreases in CO2 levels in the atmosphere by plants. it is now an average of 15 degrees Celsius, or 59 degrees Fahrenheit, a much lower temperature than what we experienced just before. The vegetation cover has expanded. Oxygen levels have increased from 15 to 25%. The atmosphere is changing. The climate is changing. Other changes have also occurred on the surface of the Earth. Seen from the sky, it no longer looks like a desert rock. We can clearly see the new vegetation that is growing. One of the striking elements of this period is the mutation of this vegetation cover. Until now, we found more or less the same specimens a little everywhere. But little by little, from minus 358 million years ago, at the beginning of the Carboniferous period, the variation in temperature between the poles and the equator favored the growth of very distinct forests, depending on the continents and regions. This is called climatic zonation. This leads to demarcations in the vegetation, and consequently, in the animal population that lives there. The coal-bearing forests develop at the equator. This is the beginning of the rainforest, so to speak. Would you like to find out more about this particular area? Then let's go. Here we are, the rainforest, in the middle of the Carboniferous period, about 320 million years ago. Forests developed in the swampy areas of the region. From this vegetation, coal, also known as coal, was produced over time, hence the name coal forest. Look at how much denser and more abundant the vegetation seems than it was a few million years ago. Here we find the lepidodendron. It is a swamp tree. The trunk is rather broad, high, and the bark is very thick. It could probably reach almost 30 meters or 98 feet high and 2 meters or 7 feet in diameter. At the top, there is what appears to be close to pine thorn foliage. Under the ground, they are not yet roots as such that allow the tree to feed itself and produce the energy necessary for its development, but rather stems. Some specimens, like the one we are lucky enough to have in front of us at this moment, had cones in their branches, a bit like the pine cone, carrying the spores, allowing species similar to lepidodendron to reproduce. These cones will give their name to conifers. The first of the genus were moored to the Earth during the Carboniferous, and some of them managed to reach the Secondary era, the Mesozoic. Then, important climatic changes took their toll on many of them, but they held on and are still there today populating our forests. A little further on your right, here is another tree that appreciates this type of swampy soil. The Sigillaria could also reach 30 meters or 98 feet in height. But its trunk, even though it is tall, is more fragile. Depending on the specimen, the trunk is single or forked. It was not formed of wood per se, but rather a layer of tightly packed leaf bases that as the plant grows becomes a trunk. Underneath what looks like a trunk, there is a base of leaves, and then in the center, the pith of the tree, which is rather fibrous. The leaves are long and thin. They look like grass gathered around a stem. This calamite is a little bit higher. Indeed, this tree horsetail could reach between 30 and 50 meters in height. That is to say, between 100 and 165 feet high. As you can see, the trunk appears segmented, a bit like bamboos. Again, there are needle-like leaves and cones of some sort. The leaves, branches, and cones seem to grow from the same node, which is what we call a whorl in botany. There is also the chordata, which you should definitely take a closer look at. there are several specimens a little further on. Let's get closer. You see, the trunk of this tree ends in a bunch of leaves. So far, nothing radically different from the first trees we saw. But look a little closer at the leaves. Touch them. Do you notice anything? It looks like leather. Long ribbons of leather from 25 centimeters to 1 meter long and nearly 15 centimeters wide. That's 10 inches to 3 feet long and nearly 6 feet wide. These leaves are attached directly to the stem. There is another plant I told you about earlier that I would like to introduce you to now. It's just around the corner. This is the fern. There are many kinds of ferns in this swampy area, including the seed fern, which carries the seeds with its foliage. Here is another one that is a bit special. We call it a giant fern. If at the level of the leaves the resemblance is rather striking with the ferns which we can see in various areas of the world, the plant is higher and often characterized by a small shrub. It is indeed part of the arborescent ferns. It is a Sauronius. Here is another species of fern, the Sphenopteris. The frond of this one can reach 50 centimeters, or about 20 inches. It seems fragile like that, but it will nevertheless last from the Upper Devonian to the Cretaceous. As what? One should not trust the appearances. This pretty fern will be used as a transition to discover the second forest which awaits us. We will find there ferns, of course, but also other trees characteristic of this zone far from the equator. We are going to make a jump of several hundred kilometers. Are you ready? Here, in what can be described as the temperate zone, we will find another type of tree, of which the Glossopteris is a part. Here are several of them. On the one in front of us, you can already see that the leaves are different from those we have seen so far. If, like me, you are a big fan of Littlefoot the dinosaur, its leaves must undoubtedly make you think of the famous tree stars that the long-necked savor with greed in this animated series. But beyond the nostalgic note of our childhood that this tree is synonymous with, it can also be talkative and tell us its past. Come closer to this one, whose trunk has probably split a few years ago. As you can see, the wood of the trunk and the branches have rings. These rings indicate that it has lived in a climate with distinct seasons, much like what we know today in temperate regions. Another peculiarity, it seems that this species had deciduous leaves. The cycle of the seasons thus seems to play an important role in this area of the world. Now that you know more about the forest and the different trees that make it up, it's time for you to go and meet its inhabitants. I hope you have good shoes. In this part of the world, during the Carboniferous period, you will be able to see for yourself how closely the flora and fauna are linked. You've already seen how much the plant cover has changed so far, haven't you? Well, you'll be just as surprised by the diversification of the fauna. Until a few million years ago, there was hardly a living soul on Earth. The different levels of the forest have a characteristic humus and litter, as well as an increasing variety of herbaceous plants, shrubs, and trees. All this favors the cycle of life, develops a food chain, and an increasingly rich ecosystem. You can see winged insects, millipedes, spiders, scorpions, amphibians, and even reptiles. Let's start by surprising you. Yes, I can assure you that this first specimen should make you react. See that flying animal flying over the bank near the river? It's not a bird. No, far from it. They will appear much later. So who is it? It's Meganeura, a giant dragonfly. Yes, you heard me right, a dragonfly. With its 70-centimeter or 28-inch wingspan, you'll admit that it's quite surprising. Other specimens of the genus are much more reasonable in size, like the Stenodictia that you can see right there with its 9-centimeter length. Let's leave the aquatic environment to fix our attention on the ground. In the Carboniferous, everything sometimes seems to be out of proportion. If you were surprised by our pretty dragonfly earlier, I believe that this millipede should also cause you to be amazed. Yes, this Acanthur pestis is indeed a millipede, despite its 50-centimeter or 20 inches long. But this is nothing compared to the one I would like to show you in a few moments. For that, we have to go a little further into the coal forest. Are you a gambler? What do you say we place a bet? How big is the Arthropleura? To find out, look at the movements under this fern. They announce its arrival. One is, if such animals were roaming our forests today, there would be far fewer people during the mushroom picking season in the undergrowth. So far, we have never crossed paths with an amphibian. You can't miss it. Let's get closer to the water again to try our luck. Here we can see what we could call protritons, that is, amphibians that breathe through gills and that probably represent the larva or tadpole of some primitive batrachians. But it is the adults that I would like to find now. Look, here is a beautiful adult actinodon. It must measure a little less than 1 meter or less than 3 feet. The eyes and nostrils are small and not very marked. We can recognize it by its triangular head, which is a bit similar to the one of the actual crocodiles. It is not only in that it resembles him, since it is equipped with pointed teeth, what makes him a carnivore. We are going to leave the Carboniferous on the image of this actinodon and progress a little more on the timescale. The magic has worked, and you have, I hope, enjoyed your passage through the Carboniferous. But our journey continues. It is already time to leave. More discoveries await you. We have arrived at the Permian. This period is literally a period of beginnings and ends. You'll see that while it allows for the emergence of new species, many others will disappear. The Permian is also characterized by a clearer zonation of our planet. There is sometimes significant precipitation around mountain ranges, while in other parts of the landmass, the rainfall rate is low. There are warm, dry regions with savanna-like vegetation and deserts, but at the South Pole, the temperature can drop to minus 30 degrees Celsius or minus 22 degrees Fahrenheit. We recognize the vegetation of the Carboniferous with the presence of Lepidodendron and Sigillaria. But little by little, a clearer demarcation between the north and south takes shape. One finds essentially conifers in the north, like Walchia, and Glossopteridales in the south. Over time, the Permian also witnessed the evolution of plants and land cover. Prehistoric plants such as lycopods gradually give way to glossopterids. Seed plants, ferns, conifers, and cycads colonized the continent and formed a new food chain that was essential for the many new reptiles to come. Another Permian phenomenon is the synapsids, on today. which both form the carnivorous branches of the synapsids, and the Edaphosauridae, which is a vegetarian group. Until now, the carnivorous diet was dominant. They are the first vertebrates to follow another diet. These three groups are attached to the Pelycosaurus, a group that seems to define their common ancestor. In the Permian, a fourth group appears. It is that of the Cassidae. They too are vegetarians. Are you ready to meet these animals? Then follow me. The synapsid in front of you is a Gorgonopsian, Lycanops. A long skull, canines, and long incisors, you can't miss him. From his teeth, he is not a vegetarian. These teeth were fearsome and sharp weapons to defeat his victims. The bite was really powerful. He may not be fast, but he is pretty smart and strategic. He uses the bites as his strike force. After wounding his victim, he hides behind. He's in ambush, ready to return to the charge if needed, then return in extremis to hide. The purpose of this maneuver? To have his victim exhausted and succumb to his wounds without taking too much risk for his own life. When the heart stops beating, he just has to enjoy his meal. In the same group, there is also the Gorgonopsian Rubigine. He was certainly the most robust of the family given his physique, but he also held the prize for the most powerful and impressive bite. In the interest of fairness, to redress the balance, let's meet an ambassador of the herbivore family. You'll easily recognize him. In addition to sporting a reptilian look, he's one of the only ones in the area to graze on ferns and other low plants within his reach. Vegetarian diet was not very common at that time. Here it is. Here is our long-awaited Dinocephalus keratocephalus. Its name means horned head. It measures between 2 and 3 meters long, or up to 10 feet, and its skull is rather imposing. Depending on the specimen and the species, it weighs between 700 and 1,000 kilograms, or between 1,500 and 2,200 pounds. The diconodont is another emblematic animal of the Permian. Vertebrate and herbivorous, it has a very particular physique. Its attractions evoke both a rodent and a turtle, but it has tusks and beaks. One of the species of the diconodont family is the Lysowicea. It is far from being a featherweight, since it is about 4.5 meters or 15 feet long, and nearly 2.5 meters or 8 feet in height. It is the largest diconodont. Right in front of you, that's 9 tons moving around. Oh look, about 10 meters away from it is a Diplocaulus. This amphibian lives near rivers and mountain streams. Its name means double cap. It owes it to its boomerang-shaped skull. For the rest, it looks a bit like a salamander, despite its meter long. Its tail helps it in its movements, a bit like a pendulum. Another primitive amphibian impresses by its size. It is the Eriops. The body measures 2 meters or 7 feet on average, but specimens reaching nearly 3 meters or 10 feet are not uncommon. In spite of this extremely long body, its head seems disproportionate. It is big, wide, and flat. The mouth is huge, and like frogs, the teeth are curved. It has 3 pairs of fangs that wait with bated breath for its next victim. Considering the size of some dragonflies, the size of its mouth should be at least proportional. But it is far from being the only predator in the area. Here is the Dimetrodon. It is a kind of rather massive reptile. which has short and powerful legs, a long tail, and a fearsome jaw. It is equipped with 2 types of teeth. While the first ones grab and hold, the other ones shear and shred. It is better to avoid putting your fingers in it. Another particularity is its dorsal veil. It allows him to support the big variations of temperatures and climate. Thanks to this veil, it can regulate the temperature by storing or evacuating the accumulated heat. If there are many carnivores, herbivores are also present. One of them is the Prehistoris. It is one of the largest reptiles of the Permian. Its body is protected by a real armor. It is covered with scales. I hope we will have the chance to see one. The term Prehistoris means cheeked lizards. These parareptiles are herbivores, and they eat an astronomical amount of food per day. Let's get closer to their favorite food. We might have a little better luck. Here they are, the Bradysaurus. Rather stocky, they have large feet to support their weight, which could reach 100 kilos for the biggest. They have a short tail, a small head, but a massive and robust body. Another member of the family, much more imposing than our Bradysaurus, is the Bunostegos. This time we are approaching 600 kilos, or 1,300 pounds. Before continuing our journey through time, you must meet 2 very important families. They are emblematic of the Permian and have marked the history of our planet and of life. The first one is the mammalian reptiles. During the Permian, as the climate dried out, the pelycosaurs declined in favor of another lineage of synapsids better able to resist it, the therapsids, whose morphological characteristics were more similar to mammals. One of their lineages will give birth to the family of mammals. They have differentiated teeth, canines, incisors, molars, premolars, hair, like the Cynognathus, limbs under their body, and not on the sides or a single temporal fossa. If I mention the term saber-teeth, you are probably thinking of the famous saber-toothed tiger. But I can assure you that this one, despite its impressive canines, looks nothing like a tiger. It is rather a cross between a turtle and a pig. Here is the Glanosuchus macrops. It has a long snout and large canines, but it also has incisors in the shape of a blade, 6 on each side. Behind the canines, 5 small pointed teeth complete the heavy artillery of the animal. The nostrils are located at the end of the muzzle and directed towards the front. This must have been a precious help during the hunt. If I wanted to show you this Glanosuchus macrops, it is because it is of particular interest. It allows us to support our approach to evolution and to better understand how it is operated on the surface of the Earth. You can't see it, yet a major change has taken place in the skeletons of some animals. We are still in the early stages, but this is the first step of an important change: the middle ear of mammals. Mammals now have 3 essential bones in the middle ear: the hammer, anvil, and stirrup. It would seem that these were formed from the joint bone and square bone of these early therapsids. The second iconic Permian family is the Archosaur family. Why archosaurs? Because they will give rise to dinosaurs, crocodiles, pterosaurs, and phytosaurs. They all have a common ancestor in the archosaurs. So who are they? The classification of archosaurs is based on shared morphological characteristics such as an anti-orbital window, i.e. a lateral opening in the skull located in the front of the orbits, but also serrated teeth and an upright position. Here are two of them. The Proterosaurus spineri first. Very slender, it looks like a lizard and has some similarities with the Monitor. It has long legs, a long neck, and can measure up to 2 meters or 7 feet long. Despite a nice set of teeth, it is not a carnivore. It feeds rather on conifer cones. Another member of the genus is hidden a little further in this mass of vegetation. The Archosaurus rosicus is, as for him, well and truly carnivorous. Its appearance is a bit unusual. Its body is similar to that of a crocodile, while the head is finally rather undefinable. It seems to have a kind of trunk, a bit like that of an elephant or an anteater, but at the same time, this pseudo-trunk forms a mouth that can open and close. Moreover, when it opens its mouth, you can see that the upper jaw is made up of 2 parts. One rests on the lower jaw, the other protrudes from the lower lip. Dinosaurs have undoubtedly marked history. It fascinates the crowds from a very young age. Many of us are attracted to these animals. Their extinction is an event that everyone has already heard about. However, this mass extinction is far from being the most important one our planet has ever known. The most serious one is happening now, at the end of the Permian. It will mark the beginning of the Triassic period, and will upset the order of things forever. 70% of terrestrial genera and almost 95% of marine genera will disappear. The origin of the phenomenon is still unclear, but the massive volcanic eruptions that you can see in the distance are undoubtedly part of it. Since then, the air has become considerably depleted of oxygen. Large parts of southern Pangea were covered by glaciers, but conditions have warmed considerably since the volcanic eruptions that marked the early Triassic. Nothing will ever be the same again. The change is too sudden and brings with it the disappearance of many species. The trilobites, although abundant until now, will be eradicated from the surface of the Earth. The species has become extinct, like many other marine animals. Others, if they have not disappeared, have been considerably affected. This is the case of the reef builders, for example. Many species of corals will not survive. Echinoderms and ammonoids will manage to survive the crisis thanks to a small handful of species. In unicellular organisms and foraminifera, the damage is considerable. On land, the situation is just as distressing. Nearly 60% of tetrapods have disappeared from the surface of the globe, as have the large herbivores, which will not be able to resist the extreme and hostile climatic conditions. They are totally dependent on plants to survive. No more vegetation, no more food. It's certain death. Despite everything, after this biological crisis, nature gradually takes its rights. Temperatures rise and the landscape changes. We can see appearing of forests much more vast. These are located near the equator and benefit from the monsoons. These are the first forests that can be considered tropical. Other ecosystems around the world have become much drier with the appearance of desert areas, which has stimulated the evolution of new types of reptiles better adapted to cope with the arid climate. Fauna and flora are constantly evolving. We are entering a new era. We leave the Paleozoic, which begins in the Cambrian and ends in the Permian, to enter the Mesozoic. We have an appointment with the Triassic. What are we waiting for to get back on the road? Triassic, here we come. We are entering the Triassic, a period that began about 252 million years ago. The large size of Pangea favors an accentuated continental climate. It is marked by very hot summers and particularly cold winters. If the monsoon settles in the intertropical zone, as we have seen previously, arid and dry areas extend elsewhere on the continent. Many plant and animal species do not survive the Permo-Triassic crisis. Lycopodiales, cycadales, ginkgophytes, and glossopterides managed to resist for a while, but over the millennia, they too gradually disappeared from the surface of the Earth, as did many amphibians and mammalian reptiles. As for the conifers, they continue their way and now constitute the essential of the vegetation cover of our Earth. As for the animals, the vegetation having changed, new species have appeared. If the amphibians disappear little by little, the few survivors will give birth to modern amphibians, such as lysamphibians. The mammalian reptiles are less and less present. All these species progressively gave way to diaspid reptiles, and in particular to archosaurs, which in turn gave birth to new branches that mark the history of life: crocodiles, pterosaurs, and dinosaurs. Even if their arrival is very discreet for the moment, some species of turtles and mammals will also make their appearance. The first mammals are of marsupial type. They are called metatherians. We have many species to discover. Let's take a closer look. Here we go. How about starting our expedition by meeting the lysamphibians? They have an aquatic life phase when they are still larvae, then a terrestrial life phase. They can be found near this stream. They only like fresh water. In the larval state, they breathe thanks to their gills. Then at the adult age, the lungs take over, even if they can also breathe by the skin. As you can see, they have 4 limbs and belong to the vertebrates. This group includes several branches, such as gymnophiones, batrachians, salamanders, anurans, frogs, toads, and kidneys. Here is one of the veterans of the group, the lysamphibians. To date, it is the oldest known to scientists. It is a Triadobatrachus masonati. It looks a lot like a frog and measures about 10 centimeters or 4 inches. Other dean in its category, the Proterosuchus. It is part of the Archosauriformes. Look, here is a Proterosuchus fergusi. Do you see it? It moves in the direction of the river to quench its thirst. This quadruped can reach more than 3 meters. It has a big head and a slightly hooked snout. As you can see, its position is tentacular. The limbs are not located under its belly, but rather on the side, hence this particular walk. This does not prevent it from lying in ambush to flush out its prey. It is an accomplished predator. It is also equipped with a mesopic vision, that is to say, that it can see at the same time in the bright light of the day, but also in the half-light. Let's leave him to his hunting. Another predator is waiting for us a little further. It is part of the emerging group of crocodilomorphs. When we talk about crocodiles today, we have the image of a rather stocky animal, not very active, except when hunting, and rather adapted to an aquatic and marine life. But at the beginning of the Triassic period, the species forming the group of crocodilomorphs were much more varied than today, and their silhouette was quite different. They are smaller, but also lighter and more active. Look, this giant and spindly lizard is one of them. It is a Pterostrasuchus gracilis. It's true that its appearance suggests a lizard rather than a crocodile, but it is indeed a member of this group. It measures about 1 meter or 3 feet for about 15 kilos or about 30 pounds. It has long, thin, and muscular legs. To maintain its balance, it uses its tail. In terms of size, it represents the double of its body. Since the beginning of our trip, we have had the opportunity to observe many plant and animal species. Through these observations, we have tried to analyze and understand the evolutionary pathway to determine the changes that have taken place over time. From observations to questions, we managed to find some answers. Now that you are almost an expert, are you ready to start this thought process alone? So, looking a little closer at this Pterostrasuchus gracilis, what could you add about the shape and position of its legs? The first element is the posture. The legs are positioned directly under the body, which has an impact on the gait, but also on the possibilities of movement. Then, the hind legs are slightly longer than the front legs. If we add to that an important musculature, we obtain a king of the race. Well, as it is clear that we will not be able to compete in terms of speed with this crocodilomorph, I think it is now time for us to continue our journey. How about discovering another branch born from the archosaurs, the pterosaurs? Pterosaurs are flying reptiles. Can you imagine how far we've come? It took a long time for evolution to allow animals to colonize the Earth, but very few of them until now had managed to conquer the sky. The reasons for this small feat are still mysterious. We still don't know how the passage from a terrestrial and probably bipedal ancestor to flying and quadrupedal animals linked to very particular ecosystems took place. Some of them were real kings of the air. Others, because of their imposing size, managed to move in the sky with more difficulty, and this required considerable energy. I am thinking of Quetzalcoatlus and Hatzegupteryx, which are very large flying reptiles. Ostreodactylus is one of the first pterosaurs. It is about 90 centimeters or 35 inches long and weighs 15 kilos or 30 pounds. When it spreads its wings, we approach 120 centimeters or 50 inches of span. What characterizes it is its crest on the front of the skull. It also has a long tail that serves as a rudder. It is, in a way, a cross between a giant bat and a wolf with a long tail. The Quetzalcoatlus northropi appeared much later, since it flew over the ground in the Cretaceous period. The one you see here looks a bit like a stork with its long neck. You're probably wondering how long its wingspan is. I won't leave you wondering any longer. It can reach 10 meters or 30 feet. As for its diet, it is difficult to determine what was its favorite menu. If at first we thought of fish, it turns out that this giant of the sky probably preferred the carcasses of small terrestrial animals. we can't cross into the Triassic without encountering a member of the Euparkerius family. Come on, we have to move and get into the outskirts of this thick vegetation if we want to meet one of them. Here it is. There, only a few meters away from us. Quadruped, and it seems to fulfill all the characteristics required to give birth to future dinosaurs. This one is a Euparkeria capensis, to be quite precise. As you can see, it is indeed a quadruped and has semi-erect limbs. If you are observant, you will also notice that the hind limbs are slightly longer than the front ones. Some researchers suggest that it could have been bipedal from time to time. When you have seen a Euparkerius, it is time to meet our first dinosaurs. How about we start with one of the oldest of them, the Dinosaurus. It is a member of the Dinosauriform family. I present you Dinosaurus parringtoni. It measures 2 to 3 meters long, that is to say up to 10 feet long, and if it stands on its 2 back legs, it is not to greet you. His front legs are shorter. Its tail allows it to maintain its balance. The dinosaurs will form 2 big families at first, the Saurischians that we will see now, and the Ornithischians that we will meet a little later. In the family of the Saurischians, there is the Musser. The animal that you see just in front of you measures barely 20 centimeters or 8 inches, and it is a Mosaurus patagonicus. But don't let its small size fool you. This one is just a baby. As an adult, it can reach 3 meters or 10 feet. Some even reach 6 meters or 20 feet long. The mother of this young Musser can't be far away. Let's be careful. Do you hear that thud? Do you feel those vibrations on the ground? There's another animal approaching, and it's not a featherweight. There it is. It's a Liliensternus. It's almost 6 meters or 20 feet long, and must be easily over 2 meters or 7 feet high. He has a small crest on his skull, and rather sharp teeth. He is hunting. Let's stay here. He is chasing this pterosaur, a flying reptile, around the river. He has no chance to get out of it alive. After this hunting episode, what do you say we get to safety in search of a herbivore? Let's go back. The animal I'm looking for is special. Its name means flat reptile. This behemoth can reach 8 meters or 26 feet in length and weigh up to 4 tons. However, this land giant feeds exclusively on plants. Its long neck allows it to reach the fresh and tender leaves of trees, located at 3 or 4 meters or 13 feet from the ground. Look, there it is. It's a platysaurus. It extends its neck or stands on its hind legs for a few minutes to reach the best leaves. Look, one of his fellow creatures a few meters away from him is swallowing insects and other vertebrates. Vegetation supports herbivores, but also small carnivores that feed on insects, for example. Other predators take advantage of the abundance of small carnivorous and insectivorous prey to feed in their turn. The large carnivores themselves feed on them, and the circle is complete. In other words, a complete food chain is created thanks to all the plants you can see in front of you. In the forest, you'll find a bit of everything, from herbivores to carnivores, insectivores, and even omnivores. This dietary diversity is made possible by the wide variety of vegetation and environments found in the Jurassic. You have to go deep into the forest to understand this. Once in the undergrowth, you can see not only the richness of the plant cover, but also the different strata of the forest, from the lowest and fullest to the highest and sparsest. You can also see how varied the genera and species are, to get to the heart of Jurassic vegetation, let's start with ferns. Yes, they're still with us today, as they may have been in the past, and they're even benefiting from new evolutionary radiations. They make up a large part of the plant cover of the period. Within this large group, there are many families, genera, and species. All families, sometimes quite different from one another, find their place within a particular ecological niche. These differences in ferns also lead to diversification in the insects and small animals that depend on them. Among Jurassic ferns, we can cite several families, such as Glycania, truncata, Osmundastrum, Dipterodaceae, while other, taller ferns, such as Dixonaceae and Cyatheaceae, are also well represented. The great diversity of these ferns plays a decisive role in Jurassic forests, as we have just said, as they form the basis of certain ecological niches. But their position in the forest also explains why they so perfectly embody this role in the ecosystem. Ferns are part of what we call the lower strata of the forest. To put it another way, they form a sort of green meadow in the undergrowth. It's a green paradise for insects, but also for small animals, which find shelter and food in abundance. Although small, not always, ferns are also home to the giant sauropod family. But we'll come back to that a little later, once we've completed our overview of Jurassic plants. During this period, ferns were abundant, but there were also many other plants. After the ferns and small bushes that form the undergrowth, there's a middle stratum and a higher stratum that make up the forest proper. This Jurassic forest is luxuriant and abundant all over the globe. Today, it's hard to imagine that vegetation could be so abundant all over the Earth, as different continents and geological zones embody different types of climate and therefore vegetation. But in the Jurassic, even on the fringes of present-day Greenland, known for its ice and biting cold, vegetation was rich and well-developed, unlike today, when it is rather low and sparse. Three main groups of arborescent plants can be identified in the Jurassic. The first group comprises conifers, also known as pinophytes. This group includes the Cheirolipidaceae, a family that is now extinct. The Araucariaceae and Podocarapaceae, on the other hand, are still around today. Pinophytes are large trees. They are easily distinguished from others by their cone-shaped fruit. These cones serve as the plant's reproductive organs. On this tree, some cones are male, others female. These trees are called gymnosperms. Reproduction requires a little help from Mother Nature, particularly from the wind, but also from a few insects of the Mecopteran family, which have been active since the Middle Jurassic. They also provide an ecological niche for small insectivorous animals that settle in the forest. Everything is linked in nature. The great advantage of these pinophytes is their ability to establish themselves in a wide variety of environments, even the harshest. In this way, they have managed to colonize a large part of the world's landmass, even intertropical regions or salty environments, near coasts and maritime zones, for example. But this will not be enough to compete with angiosperms, the flowering plants that will soon occupy a large part of their territory. In addition to pinophytes, the forest is also populated by ginkgophytes. These species of ginkgos are the dominant trees in the canopy. They can reach up to 40 meters or 130 feet in height. Ginkgo digitata and adiantoids can be seen in this forest. Digitata trees have fan-shaped indented leaves. These species thrive in tropical and semi-tropical climates. The absence of cones and their famous palmate leaves distinguish them from previous conifers. These species will also provide new opportunities for the young fauna that gradually settled on planet Earth during the Jurassic period. Let's return to the lower forest stratum. In this region, it is also colonized by another type of plant, the cycads. The most dominant and emblematic group of the period is undoubtedly the so-called cycadophytes. Cycads are far from reaching the heights of the previous group. Their foliage covers the lower forest floor, rather like ferns. They are found mainly in tropical zones with their characteristic hot, humid climate. This tropical zone is a highly favorable environment not only for these plants, but also for the many insects and small animals that depend on them. Some of these species, such as Pseudotenis and Nilsionia, look a little like palm trees, with a crown of large leaves that fall and form the trunk. Horsetails are also very common, especially in these same wetlands. These plants can serve as food for a number of herbivores, thus promoting the development of a balanced food chain and a stable ecosystem. It's true that while these lower strata benefit insectivores and small carnivores, we can see here that herbivores also find plenty to eat. Among the horsetails, there are two major species, very popular at the time: the neocalamites and the equisetails. In addition to their great diversity of plants, these forests are home to a wide variety of environments. There are jungles such as one might imagine in the Amazon, swamps and low-lying plants, large clearings where the sun floods the ground with its heat, and coastal landscapes. All these environments form diverse ecological niches, and thus benefit a wide variety of species. It's time to go and meet them. Let's stay on the edge of the forest near this swamp and begin our discovery of Jurassic fauna with a group we've been following for some time now, the amphibians. You were expecting to talk about dinosaurs, weren't you? When you think of Jurassic fauna, you immediately think of dinosaurs. They're the emblematic group of the Jurassic and probably the most important of the animal kingdom during this period. But we sometimes forget that many other species contributed to weaving a veritable ecosystem in which these dinosaurs were able to flourish. Each of these species is part of a greater whole, and each has a role to play in the survival of the others. Dinosaurs were far from the only species to occupy the Earth at this time, and the different groups we're now going to look at undoubtedly contributed to their rise. Let's get back to our famous amphibians. During the Carboniferous and Permian periods in particular, amphibians were the main terrestrial predators, so to speak. Their size was sometimes much greater than we would have expected from the amphibians we know today. By the Jurassic period, they had largely lost this prominent position. Despite their great size, the amphibian population declined considerably, to the benefit of new species. After the Triassic crisis, the arrival of the first dinosaurs and the great diversification of lizards, these animals saw their ecological niche shrink dramatically, all of which logically led to a population decline. When there's no more food and a loss of territory, the species slowly dies. Despite this, a few managed to survive the Triassic period. These even managed to settle comfortably into the Jurassic. So all is not lost for our amphibians. During the Middle and Upper Jurassic, we discover a group that continues to grow to the present day through three major families. These are the Lysamphibians. They form the only surviving group of the amphibian class. This pretty Viorella near this watering hole is a great opportunity to get to grips with the new families of Lysamphibians. It's probably one of the oldest frogs and a member of the Anarin family. Feeding on insects, this little Viorella measures just a few centimeters long. However small, it already displays the physical characteristics of frogs as we know them today, including the shape of its head, large eyes, and muscular legs. Without knowing its group or lineage, it's easy to imagine that it's a primitive frog just by observing its behavior and silhouette. The Lysamphibians include the Anarin family and frogs like the one we've just seen. Lysamphibians also include the Urodal family, i.e. salamanders, and the Gymnophian family, vermiform amphibians also known as apodes or Cecilia. It is these last two families that will interest us now. Still in the Jurassic marshes, an insectivore quite different from Viorella roams the same environment. This time it's one of the very first salamanders, according to the latest paleontological research. Carorus sharovi has all the trappings of a salamander. Its triangular head, upward pointing eyes, and distinctive legs are all distinctive. It measures around 20 centimeters or 8 inches. Its head seems flatter than today's salamanders, and the triangular shape is also more pronounced. Studies of Carorus fossils suggest that this small primitive salamander fed on snails, worms, crustaceans, and perhaps even insects. It thrives in freshwater, where it finds everything it needs to survive. In the early Jurassic, a worm-like amphibian also appeared. We rarely think of this type of morphology when we think of amphibians, but worm-like caecilians are indeed part of this large family. They like damp, dense, warm forests, and in marshes, particularly those of North America, this Eosocilia finds plenty to do. It measures around 15 centimeters or 6 inches long. It is therefore quite discreet. Unlike the modern caecilians we meet on the continent, this one hasn't lost its legs. If you're observant, you'll see that it has 2 small legs at the front, shortly after the head, and 2 more at the back, close to the tail. Modern caecilians have poor eyesight and often live underground. It is therefore possible that our Eosocilia micropodia, with its legs and eyes a little more developed than modern specimens, enjoys the great outdoors more than its descendants. Like the other amphibians we met, it feeds on insects of all kinds. It has to be said that over the course of time, they too have diversified considerably. The Diptera group, which includes flies and mosquitoes, has seen an explosion of new species. In this swamp, a Tarsophlebia dragonfly can be seen here. A little further on one of the very common seed plants from the Triassic to the Cretaceous, the Bennettitails Weilandiella, we can also see a new type of dipteran, no doubt a close relative of the cousins. Another small insect, about 6 millimeters long, called Gallimosovelia grioti, can also be seen on the lake. According to the paleontologists who have worked on the subject, this is a water spider and probably the oldest fossil of an aquatic insect of the order Geromorpha ever discovered. This region is ideal for observing insects, so let's stop here for a few moments to take a closer look at a few of them. As we just mentioned, mosquitoes and flies have also undergone a major radiation and population explosion. Climate and the expansion of vegetation have greatly favored the rise of this type of insect. But that's not the only reason. The first insects appeared as early as the Paleozoic era and were mainly terrestrial at first. But the acquisition of wings, and therefore the ability to fly, greatly expanded their range of niches, and by extension, their territory. We find Hymenoptera, including bees, wasps, and ants. Lepidoptera, with 2 pairs of membranous wings, such as butterflies. Diptera, with 2 pairs of wings, such as flies, mosquitoes, and horseflies. And Neuroptera, including lacewings and anteaters. One of the most represented groups of Diptera in the Jurassic is undoubtedly the Stratileidae. This group comprises 2 genera, Stratilia and Vocilla. These flies have wings, contrary to what scientists first thought when studying fossils, particularly those preserved in amber. What led them astray were the fossil remains, without wings. The explanation actually lies in their deciduous wings. Like many modern insects, such as ants, these flies probably lost their wings after mating. Sexual dimorphism is also noticeable in these species. Males have enlarged hind legs. This can be explained by mating requirements, since during their lovemaking the male has to position himself above the female and hold on with his hind legs. Lacewings are neuropterans, characterized by 2 pairs of equal-sized membranous wings with numerous clearly visible veins. Jurassic lacewings have much to teach us. Fossils, for example, have revealed that these insects were already using camouflage as a means of survival, particularly in the larval stage. They blend into the background, make themselves forgotten, and can thus hope to slip through the net of nearby predators. Polystoicotes punctata, commonly known as the giant chrysopod, first appeared in the Jurassic period and was still around until the 1950s to 1960s. Incredible as it may seem, the giant lacewing seems to be back in the news. A specimen was found in Arkansas, USA, in 2012, but it wasn't until 2020 that entomologist Professor Michael Sfarla made the connection with Polystoicotes punctata. Insects don't just thrive in the forest. In the aquatic environment, many species are also abundant. Another giant insect. Yes, the Jurassic period also saw insects of rather exceptional size. But fortunately for us, Morrisonepa, unlike the giant lacewing, has now disappeared. Morrisonepa is one of the giant water bugs, like the genus Lothosaurus, and the latter are not renowned for their beauty or gentleness. These insects are extremely painful to bite, injecting their prey with a saliva packed with enzymes that break down proteins. No chance of escaping. Using its proboscis, the giant bug simply sucks up the delicious cocktail of the prepared mixture, a semi-digested bodily liquid from the prey. If Lothosaurus can prey on snails, crustaceans, fish, amphibians, or even snakes, it may be that our Morrisonepa has the same culinary tastes. Other forms of insects are also making their appearance. As we'll soon see, dinosaurs, particularly feathered ones, but also furry mammals, also emerged in the Jurassic. These feathers and hairs offer new opportunities for insects, which can easily attach themselves to their new hosts. Fleas, for example, which are hematophagous insects that feed on blood, made their grand entrance into the animal kingdom to the great displeasure of their hosts. Finally, it was in the Jurassic period that the very first snakes appeared. One of the world's oldest snakes, Diablophis, can be seen here. Diablophis, as well as Portugalophis and Parvoraptor, are primitive snakes. Of course, they have much in common with our present-day snakes, notably the particular shape of their skulls, but they also have a few differences. According to fossil studies, even if the remains are few and often incomplete, paleontologists have reason to believe that these snakes still had their legs. If we summarize the Jurassic context seen in this first part of the video, we can see that plants, insects, amphibians, snakes, and other small animals of the forest and lower vegetation provided a rich ecosystem and varied ecological niches. Each in its own way helped the expansion of the dinosaurs. It's impossible to talk about Jurassic fauna without mentioning dinosaurs, of course. So here we are at last, right in the heart of the Jurassic, facing those famous dinosaurs. They are the emblematic animals of the period. They were very diverse in the Jurassic period, but also very numerous. Remember, dinosaurs first appeared in the Triassic, but their presence was still rather timid. And then, after the crisis, some of them didn't survive. However, the Jurassic did not mark the end of this great group. Quite the contrary. Dinosaurs took over the period and reigned supreme in the four corners of the world. But not everything happened in a day. For them, it all began with the archosaurs, their common ancestor, an animal clade that includes crocodilians, birds, pterosaurs, and of course all dinosaurs. What all these seemingly different species have in common is a particular feature of their anatomy, the gizzard. This muscular part is used to crush hard food. Over the millennia, archosaurs formed various lineages, including the one we're particularly interested in now, the dinosaurs. Their emergence was still rather fragile at the beginning of the Triassic period, especially as the first specimens were already facing major difficulties that were to slow down their evolution initially, the biological crisis that marked the end of the first Mesozoic period. First of all, it took time for nature to recover from the obstacles placed in its path. The Jurassic therefore represents an initial period of calm. The Lower Jurassic in particular is a transitional period when nature and the living world gradually reassert their rights. Some species die out, others survive, and that's about it. No major radiation, no demographic explosion of any species. But once the Lower Jurassic is over, the Middle Jurassic is marked by a great explosion of diversification and the development of numerous species. This demographic and radiative explosion continues into the Upper Jurassic, and the vast majority of these species belong to the vast dinosaur family. From the Middle Jurassic onwards, the era of the dinosaurs was truly established. Adaptations, radiations, evolutions, diversifications, demographic explosions, everything came together for dinosaurs to become major players in the Jurassic period, and more broadly, in a large part of the Mesozoic. While two major groups of dinosaurs had already appeared in the Triassic, the diversity of ornithischians and saurischians exploded in the Jurassic. Among the ornithischians, mainly herbivores that moved in herds, three major groups appeared that were to expand the dinosaur family: the theriophores, the ornithopods, and the marginocephali. The suborder theriophores means shield-bearer in ancient Greek. This gives you a clue as to what makes this group so special. Although they are mostly quadrupedal herbivores, their distinctive feature is their backs, which are armored with bony plates, spikes, or spurs, depending on the species. As we saw when discussing vegetation earlier, there were several strata in the plant cover. Low-growing plants were one of the favorite foods of the dinosaur that now awaits us. It's a very popular dinosaur, recognizable by its famous bony plates alternating in two rows on its back. This is the famous Stegosaurus. His body is quite stocky, but his head is rather small compared to the rest of his body. Scientists are still debating the usefulness of Stegosaurus's bony plates, but several interesting hypotheses have been put forward. One of these is that they may have been used as a deterrent, or even a defensive device against predators. Stegosaurus, especially juveniles, were preyed upon by dinosaurs such as Allosaurus and Ceratosaurus. Recent research also suggests that these plates were gorged with blood, and therefore sported a bright red hue that could also greatly intimidate any bold predator. But it's also possible that these famous spikes are simply a courtship tool, or that they have a thermoregulatory function. If they are also vascularized, they can act a bit like a solar panel, capturing heat and transmitting it into the bloodstream to warm the animal's body. But in other circumstances, such as when the animal shakes its plates, it can actually cool its body. In other words, he's got both air conditioning and heating at his fingertips. To get around, he had a good footing on his 4 legs. It has 3 little toes on its front legs and 5 on its hind legs. There are pads under each of them. On the other hand, his posture is a little unusual. If you look at its silhouette, you'll see that its front legs are shorter than its hind legs. The tail is well above the ground, while the head is relatively low. This morphology can be explained by the type of food it consumes, since it feeds on plants low to the ground. It has a beak and small teeth that enable it to cut and chew plants. Another type of dinosaur had bone plates, but they are quite distinct from those of the Stegosaurus. Here's a Nodosaurus, a Borealopelta to be more precise. As you can see, it has a bony plate that forms a sort of band, a bone nodule, hence its name, nodule lizard. The fossils of this Nodosaurus have enabled scientists to study, among other things, the remains of its stomach. We therefore know that it was a great gourmand, particularly fond of the ferns that carpet the forest floor. It must have consumed large quantities to meet its colossal energy requirements. The animal weighed over a ton and was almost 5 meters long. To facilitate digestion of these fatty ferns, the animal also swallowed the occasional stone. As its jaw wasn't much help when it came to chewing, it had to use gastroliths to make the most of the plants it ingested. Let's take a look at one of these cousins, a dinosaur best known for its distinctive tail. You may recognize it from the Ankylosaurus. It's more massive. Some 8 meters long, 2 meters or 7 feet high, and almost 4 tons rest on those 4 impressive legs. Unlike other members of the Theriothera family, he doesn't just have a body covered in thick armor. It also has a large club at the end of its tail. The last caudal vertebrae fuse together to form the club. He also has tendons that enable him to direct and manipulate this club, in particular, to give it a certain impulse to parry or deliver blows. This asset enables him to defend himself against the predators that are rampant in the region where he lives, the riverside forests. But when attacked, he also tended to flatten himself on the ground and wait for the right moment to use his club. Do you have any idea why he adopts this peculiar behavior? If you look closely at his breastplate, you'll see that it covers a good part of his body from head to tail, but not his belly. This is his Achilles heel, his weak point. It's his Achilles heel, his weak spot, and he needs to protect it first if he's to survive in battle. Another peculiarity of this dinosaur is that it also swallowed stones to facilitate digestion of the plants it ingested. This is very common in dinosaurs that don't chew well or have sufficiently developed teeth to do so. Let's take a look at another type of dinosaur, the Ornithopoda. They may not be the most familiar to the general public, but they are one of the most successful and longest-lived dinosaur lineages. Just look at the great diversity of subgroups that define this branch. Fabrosauridae, Heterodontosauridae, Hypsilophodontidae, Iguanodontidae, Hadrosauridae, and each of these subgroups has a large number of species. This time, the ornithopods, unlike the theriophores, are herbivores for the most part, but walk more easily on 2 rather than 4 legs. Fabrosaurs are the oldest ornithopoda, but also the most primitive. They were very small compared to other groups, between 60 and 120 centimeters, or 24 inches and 47 inches. Heterodontosaurs were already a little more developed. We see the horny beak appear, but also more complex teeth. Heterodontosaurus, for example, sported 3 types of teeth: sharp teeth that formed a real jaw with fangs, and wide teeth for crushing plants. A new specimen of this group was discovered in 2012, even though it was discovered much earlier. Pegomastax africanus is an astonishing little animal, measuring 45 centimeters or 18 inches long. While its skull is reminiscent of a parrot, its body is more like that of a porcupine and its teeth more like those of a small feline carnivore. Despite its sharp fangs and canines, it's definitely a herbivore, and perhaps even frugivorous, to be quite precise. According to descriptions by Paul Sereno, an American paleontologist from the University of Chicago, the fangs helped it to pick up plants, particularly fruit, and the small teeth in front of the canines were used to cut up the plants. It's also possible that these teeth were used to defend against predators or to protect their territory, for example. The Hypsilophodontidae group is best illustrated by Hypsilophodon. They can be found in every corner of the globe. They are larger than the previous ornithopods we have encountered. Hypsilophodon can reach 2 meters or 7 feet in length and weigh around 25 kilograms or 55 pounds. Its beak, quite similar to that of a turtle, enables it to cut the vegetation on which it feeds. As for its gait, its skeleton seems to indicate that it is undoubtedly a good runner. But the latter is of particular importance here, not because of its running prowess, but because it may have given rise to the next 2 lineages, the hadrosaur and the iguanodont. This time, the latter evolved mainly on 4 legs. However, it's not impossible that they were able to run on their 2 hind legs to escape, for example. Iguanodon was the second dinosaur to be discovered in history. The name given to this group is linked to their teeth, which are quite similar to those of the iguanas we know today. They are savanna dwellers. It feeds on ferns, but also on arborescent plants such as conifers, cycads, or ginkgos, for example. He was able to get to grips with them, as he was able to chew for a long time. We mentioned this earlier in connection with vegetation, and it's important to make it clear here. As you can see from the presentation of these first dinosaur species, all the plants we have seen above provide an ecological niche for dinosaurs that are very different from one another. Ankylosaurs like low-growing plants like ferns, while others like Iguanodon are better equipped and taller, and can take advantage of arborescent plants like conifers or ginkgos. Let's close this little plant parenthesis and pick up where we left off with the study of dinosaurs, and iguanodonts in particular. With research and discoveries evolving day by day, each time revealing a new facet of our distant history, the genus Iguanodon is in the process of being redefined, if we can put it that way. Certain species of Iguanodon, for example, are sometimes given different names, such as beryllium, dolodon, Hypsilospinus, Pterylion, or Wadhurstia. Nevertheless, let's try to establish some general characteristics of the genus by studying Iguanodon bernisartensis. At 5 meters or 16 feet high and 9 meters or 30 feet long, it weighs almost 5 tons. This makes it one of the larger dinosaurs. This herbivore nevertheless had plenty of predators. To defend itself, it's possible that its thumb was a great help. At the very least, it enabled him to curb the ardor of his adversaries. In fact, his very sharp thumb turns into a dagger against carnivores when our Iguanodon feels threatened. Another specificity of the genus is its famous duck-like beak and prehensile tongue, which enable it to tear up vegetation. The subject of its limbs and gait has long been a matter of debate among scientists. Is it a quadruped, a biped, bipedal only in its prime, or when juvenile? Although a few discoveries, notably in 2000, have cleared up a few mysteries, the vagueness is still quite relative. Its long, heavy tail is the main reason for questioning its approach in the first instance. To understand ancient species, we rely on our knowledge in comparison with current species. Here, scientists see some semblance of a kangaroo. Its strong, muscular tail could provide support for the animal, which would then walk on its 2 hind legs. But in the 2000s, paleontologists brought to light an essential new feature of the Iguanodon skeleton. Its caudal vertebrae are connected and rigidified. The first thesis no longer holds. It would seem that the tail is more a kind of balance beam, or even, depending on the situation, a counterweight. Although it moved mainly on its 4 legs, it's not impossible that it also moved from time to time on its 2 hind legs, perhaps to run and escape. The strength of herbivores to defend themselves lies above all in the horde. In a group, you're stronger. They protect each other. Iguanodons were no exception to the rule. They may also have formed part of an interspecies horde, alongside ankylosaurs, for example, to increase their chances of curbing the ardor of nearby predators. Especially as these dinosaurs did not feed on the same plants, they had everything to gain and nothing to lose by joining forces to preserve their safety. Let's take a look at the last group of ornithopods, the hadrosaurs. According to certain paleontological studies, hadrosaurs are descended from iguanodonts. It's true that they share many common characteristics. For example, they share the duck beak. Hadrosaurs have a flattened skull, enlarged in the shape of a beak to enable them to reach and gather leaves from trees in tropical forests. This ability and their dentition are assets. They will thus be favored in future evolutionary radiations over other herbivores that need gastroliths, for example, to digest plants. Hadrosaurs were fairly widespread in the Jurassic, but will be even more so in the Cretaceous. They settled all over the planet, in Asia, Europe, and North America, In fact, it was in this region that a new specimen of the genus was discovered in 2021 by students at the University of Reading in Canada. Many types of dinosaur have already been found in the region, but this time, what makes this particular fossil so unique is its age, its state of preservation, and in particular, its fossilized skin. There's no doubt that these latter elements have a lot to tell us, especially since this Hadrosaurus is thought to be a juvenile. Paleontologists may also learn more about the growth and development of these dinosaurs. Let's take a look at our final group of ornithischian dinosaurs, the marginocephalans. The marginocephalans are a special clade of dinosaurs. Although they are all herbivores, they can be bipedal or quadrupedal. What they have in common is the narrow horizontal ridge of bone at the back of their skulls. This group was to develop more extensively in the following period, the Cretaceous. But some of its members can already be seen on the Jurassic Plain. One of the best-known groups of marginocephalans is the ceratopsians. They were the group's first members. They appeared at the end of the Jurassic in present-day China. Unlike their future descendants, our first ceratopsians did not yet have the famous ruff like that of the famous Triceratops. They have an armored body and a rostral bone in the jaw. This beak-like bone enables them to tear up plants with disconcerting ease. This jaw can be seen in action in Psittacosaurus, for example. Bipedal, it is the size of an antelope. Like our modern rodents, its teeth are self-sharpening. They wear down to create a sharp edge that can cut through the toughest plants. Despite its effective jaws for cutting plants, it is not yet very well equipped in terms of digestion. It must therefore use gastroliths to crush food in its digestive system. Many Psittacosaurus fossils have been found. In some cases, up to 50 gastroliths have been found. Paleontologists believe that these gastroliths may have been stored in the gizzard, the muscularized part of the stomach. Our Psittacosaurus closes the chapter on ornithischians. Now it's time to discover the member of the second dinosaur clade, the Saurischia. In the Jurassic, the Saurischia also largely continued their evolution. The branch led to birds. Within this group of dinosaurs, two main subgroups soon emerged: the theropods, mostly bipedal carnivores, and the sauropods, large quadrupedal herbivores. Let's start with the theropods, which underwent a meteoric diversification. As we saw earlier, many herbivores populated the Jurassic soil. Herbivores meant prey, and prey meant predators. While herbivores were numerous, carnivores were also widely present. One of the best-known Jurassic predators is undoubtedly the Allosaurus. Often confused with Tyrannosaurus, Allosaurus is one of the great predators of the Jurassic. It has a huge jaw, crenellated and curved teeth that enable it to tear flesh, and if it loses a few of them in an over-aggressive attack, they soon grow back. In addition to this extraordinary dentition, he also has short but robust forelegs. They are useful for grabbing prey and holding on tight. He also uses them to butcher his victims. The hind limbs are longer, but just as vigorous. They are also equipped with claws. Carnivorous and perhaps occasionally a scavenger, Allosaurus can also hunt in groups to attack large Jurassic herbivores. There's no stopping it. This bipedal dinosaur is perfectly equipped to be a top Jurassic predator, but it's not the only one to covet this position. Let's take a look at the Megalosaurus. At 7 meters or 23 feet long and 3 meters or 10 feet high, it's quite imposing. It was the very first dinosaur to be described and given a name. In fact, it means great lizard in ancient Greek. It has many of the same characteristics as the Allosaurus. These include short, clawed forelimbs, longer, sturdier hind limbs, and a crenellated, blade-like jaw. It was one of the most feared predators of the Jurassic period. In another genre, there are also dromaeosaurs, which began to emerge very slowly in the Jurassic, but would become more widely established in the Cretaceous. This time, we're dealing with a medium-sized carnivore. Its distinctive feature is that it is covered in feathers. At least that's what the latest research has revealed about it. It shares many characteristics with primitive birds. Body shape, feathers, legs, and the famous claw on the second finger are just some of the bird-like features. This group of dinosaurs brings us to the avian dinosaurs, such as Archaeopteryx. Archaeopteryx is another type of feathered dinosaur. It has all the attributes of certain birds. However, its reptilian side cannot be ignored either, with characteristics that define it as a small bipedal dinosaur akin to a Compsognathus, for example. This strange bird is undoubtedly the one that makes the link between dinosaurs and birds. With its claws and long tail helping it to maintain balance, it can easily hunt insects and small animals. Speaking of small animals, isn't the Jurassic known as the Age of Giants? So what's really going on? If we look at the fossils of the largest known dinosaurs, a certain number can be placed in the Cretaceous period rather than the Jurassic. So why do we refer to the Jurassic as the Age of Giants? Is it a linguistic error? Misinformation? A popular misconception? No. The Jurassic can indeed be recognized as the era of the giants. The huge, long-necked sauropods were very numerous during this period, with a wide variety of species, justifying the term Era of the Giants. Let's go and meet them. Despite their immense size, we have nothing to fear. These giants are herbivores. Incidentally, to popularize the history of dinosaurs, the term herbivore has been used until now, but it's better to call them vegetarians. Grass didn't appear until the following period, the Cretaceous. With that in mind, let's take a closer look at these famous Jurassic vegetarians. The first one we're going to meet is a Diplodocus. According to scientific estimates, Diplodocus halorum measured 30 meters or 100 feet and weighed 24 tons. Its neck is almost 6 meters or 20 feet long, enabling it to reach food inaccessible to many herbivorous dinosaurs. It can reach the tops of trees, such as conifers, but it can also extend its neck and feed on aquatic marsh plants or horsetail beds. Its extremely long tail is also very useful. Made up of 80 caudal vertebrae, it acts as a counterweight, but can also be a powerful deterrent to predators. According to a hypothesis put forward by certain paleontologists, this massive tail also plays a role in courtship. To demonstrate their power, males would slam this giant whip to the ground. They estimated that the noise generated during these parades could have reached 200 decibels, a sound more powerful than a plane taking off at less than 100 meters or 330 feet. Diplodocus shares its territory with other gigantic animals, such as Bothria spondylus, another Jurassic mastodon classified as a sauropod, measuring almost 20 meters or 66 feet long. The Brachiosaurus genus is undoubtedly one of the best known to the general public. The full name of the genus's only species is Brachiosaurus altithorax. It too is one of the largest animals ever to walk the earth. It measures around 25 meters or 82 feet in length, and no less than 12 meters or 40 feet in height. Each of the vertebrae in his neck measures 70 centimeters or 28 inches, and he has 12 of them. Despite his oversized body, he has a small head. His guilty pleasure? The famous large trees we saw in the forest in the first part of the video, but also the cycads with their tender, tasty leaves. Despite its immense size, a serious competitor will soon be arriving in the Cretaceous, the Titanosaurus. After a long stroll through these Jurassic forests, it's time to see what's going on below sea level. The ocean is teeming with extraordinary creatures. Since the Triassic, the marine world has also undergone many upheavals. At first glance, terrestrial fauna is rich and diverse. But what about underwater life? Is underwater life also flourishing? Let's find out. In the heart of the Jurassic Ocean, of course, we find many of our famous shell animals, which form one of the bases of the food chain. Some of them are very special. We first encountered them in the Triassic, and they continued their reign of the shallows during the Jurassic. These are the ammonites. They are so numerous and diverse that scientists consider them to be stratigraphic markers. In other words, depending on the fossil species found, they are able to determine the age of the soil. Ammonites are therefore abundant in the ocean, providing a veritable food source for small and medium-sized predators. But ammonites are not always easy prey. At least some species are undoubtedly difficult to attack by small predators. Indeed, paleontologists have unearthed an ammonite measuring almost 2 meters or 7 feet in diameter. While these cephalopods are literally swarming all over the world's waters, they are far from the only ones to roam these marine territories. Predators are on the prowl. In the Triassic, we were able to see some great marine reptiles, such as the Nothosaurus. Unfortunately for them, despite their impressive power, they were unable to survive the crisis that marked the end of this period. The majority of the marine reptiles of the time, such as hooposuchians and thalattosaurians, suffered the same fate. Only one group managed to defy the climatic changes and geological obstacles imposed by nature during and after the Triassic crisis. It's the ichthyosaurs. Thanks to the latest discoveries by paleontologists, we now know that these marine reptiles were warm-blooded animals and that they gave birth to their young in the open sea. Skeletons of embryonic ichthyosaurs have been found inside the bodies of adult individuals, sometimes even in a position indicating that they were ready to give birth. Their size varied greatly from species to species. The smallest measured barely 1 meter or 3 feet in length, but the largest specimens could reach 20 meters or 66 feet. If they are often compared to dolphins, it's not just for their elongated snouts and sharp teeth, but for the similarities in their way of life. They are adapted to a pelagic lifestyle, but can also descend to the depths. They feed on fish and ammonites. Despite their formidable rise and great adaptability, the ichthyosaurs were to face stiff competition from the massive arrival of the plesiosaurs. Plesiosaurs were another major group to emerge in the Triassic, completing the large family of Jurassic marine superpredators. They have small heads, long necks, and bodies similar to turtles. They are also characterized by a short tail and 2 pairs of large fins. Plesiosaurus is a typical species of this order. It measures up to 5 meters or 16 feet in length. Its neck alone accounts for a large part of its length. Contrary to popular belief, its neck was not very movable. It was even rather stiff and unable to bend to feed, as swans, for example, can. It occupies more or less the same ecological niche as our Ichthyosaurus. In other words, it gradually took its place. It fed on fish and small prey, such as belemnites, animals belonging to the cephalopod clade. A fetus was found in one of the fossils studied, enabling scientists to confirm that plesiosaurs were viviparous. The female gave birth to just one offspring at a time. Guided by her maternal instinct, she took care of him during his early years, taking the time to teach him everything he needed to know, such as how to find the most beautiful belemnite specimens. This way, he could fend for himself later on in this blue immensity. The Pliosaurus is another of the most ferocious marine reptiles found in waters all over the world. It even terrorizes other marine reptiles, such as our Ichthyosaurus. Its jaws, armed with 130 sharp teeth, are enough to make the ocean tremble with fear. Long and razor-sharp, they kill with one clean stroke. Its size is matched by its formidable dentition. It could reach 13 meters or 43 feet in length. Its swimming legs, 4 powerful limbs, propel it at high speed so that it can charge at its victims. The Pliosaurus is rightly nicknamed the T-Rex of the seas. Pliosaurs aren't the only ones to conquer the ocean. Crocodiles are also taking to the sea. To illustrate the crocodilian order, I suggest you discover Cricosaurus bambergensis. It lives in shallow seas, particularly near archipelagos, where it finds everything it needs to survive. Contrary to the image we have of crocodiles, whose ancestor it is, it shares some similarities with other aquatic animals, such as dolphins. In particular, it has a caudal fin and limbs that are more akin to swimming legs than to functional legs for terrestrial mobility. Rather voracious, reactive, and fast, it doesn't hesitate to pounce on squid or fish. During the Jurassic period, a new lineage of marine turtles appeared in the aquatic world. Fossil remains of sea turtles have been discovered in Bavaria, southern Germany. The Solnhofia parsonsi turtle. This isn't all that surprising when you consider that the region at the time was, unlike today, a kind of tropical archipelago. The sea was shallow and populated by sponge reefs of all kinds. While it's easy to recognize a turtle's silhouette, a few details show that they were not yet as evolved as our modern-day turtles. Their legs, for example, are not yet paddle-shaped, but rather finger-like. This means they can move more easily along the coast. Secondly, unlike our turtles, they are not equipped with the famous salt-eliminating glands. They do, however, have the same pointed snout and triangular head. Other species, notably those in the Plesiocheilus and Thalassemus genera, populate the archipelago. These turtles had to be wary of a powerful predator that roamed both fresh and salt waters. Hybidus lived in the same geographical areas as certain marine reptiles and crocodilians. While the latter was undoubtedly preyed upon by marine reptiles twice its size, this did not prevent it from finding plenty of prey to sink its teeth into. It is a durophagous predator, meaning that no hard shell or prey frightens it. It feeds not only on belemnites, but also on other small prey, thanks to its specialized teeth. Its teeth are wide and flat, designed to crush and crush. They move quickly with their well-developed pectoral fins, making them a rather active and voracious predator. To reproduce, hybidonts lay their eggs in the water. A sort of spiral egg case was attached to the marine vegetation by a small tendril. We'll now leave the aquatic world behind us on the images of this little chord of life and head for the sky. As we already saw when we looked at the Triassic period, the wide diversification of insects and their growing population in the forest heights, as well as the presence of large predators on the ground, favored the expansion of flying lizards. During the Triassic period, one of the first groups of pterosaurs, the Rhamphorhynchids, appeared. Small in size, they were still quite primitive. But the Jurassic changed all that and shook things up a bit among these sky gods. Whereas in the Triassic we could admire Eudimophodon with a wingspan of around 1 meter, by the Jurassic, species such as Rhamphorhynchus with a wingspan of 2 meters or 7 feet were appearing. But it's far from the only one to roam the skies. One of the largest Jurassic pterosaurs is Dirkgiakonath with a wingspan of 3 meters or 10 feet. The Middle Jurassic also saw the emergence of a new family of pterosaurs. They are called pterodactyls. They can be distinguished from the more primitive pterosaurs by their shorter tails, absent fifth toes, and fewer teeth. They are generally smaller than our previous pterosaur specimens. Their average wingspan varies up to 1 meter or 3 feet in length, but some reached a wingspan of 3 meters or 10 feet in the Jurassic. These carnivores feed on fish, but also on small land animals on occasion. To help them in their predatory task, they are equipped with 90 small, fine, conical teeth. Large numbers of pterosaurs appeared in the Jurassic period. Although species diversified and developed even more widely in the Cretaceous, it is clear that they were beginning to make their mark on the Jurassic sky. If the pterosaur branch is diversifying to such an extent, it's because numerous niches among the sky gods are taking shape. To find their place, they had to adapt to their environment according to their needs. Pterosaurs come in all diets, insectivores of course, but also piscivores, filter feeders, and duraphages in the marine world, and carnivores, herbivores, and omnivores on the mainland. There are also changes on land, with new small mammalian animals. In addition to the ever-popular dinosaurs that marked the history of the Mesozoic, mammals also made a timid appearance, as early as the Triassic, and continued their slow evolution during the Jurassic. Indeed, amidst the thousands of dinosaurs, it's hard to find a place for mammals in the Jurassic living world. Nevertheless, mammals did not give up. Biological crisis or lack of adaptation, vacancies are forming in certain environments. One man's misfortune is another man's gain. These ecological niches were soon exploited by newcomers. During the Triassic, in the center of Pangea, the climate was rather dry, but following the breakup of Pangea, the climate became hot and humid. As a result, vegetation flourished, and as we've seen several times, lush jungles soon covered a large part of the land, benefiting a large number of animals: dinosaurs, reptiles, pterosaurs. But not only. Some species will adapt and take advantage of this particular environment to occupy a tropical and arboreal environment. These include small, arboreal animals such as the Shenshu and Jianshu genera, and mammals. Shenshu is a small animal measuring 18 centimeters or 7 inches, with a long tail of 20 centimeters or 8 inches, and a weight of around 300 grams. Its prehensile tail is one of the features that led paleontologists to classify it as an arboreal animal. The Jianshu genus comprises 2 species, the linglong and the sonjie. They differ from the Shenshao genus despite some similarities. The first incisor is distinctly smaller in Jianshu, and it also has ovoid molars. Measuring around 20 centimeters or 8 inches long, it weighs just 40 grams, according to scientific estimates. Linglong is slightly larger, weighing around 80 grams. What's most striking about these 2 very special genera is not so much their arboreal nature, even if this shows a formidable adaptation within the mammalian lineage. It's also the emergence of the characteristics of the first mammals. In addition to their dentition, notably the mandibular joint characteristic of the mammalian clade, we can also see by observing their fossils that the skeleton has 3 very specific bones in the middle ear. This means they were equipped with eardrums, which transformed air vibrations into sound. This shows that mammals are able to establish themselves over the long term by occupying specific ecological niches, diversifying, adapting, and evolving. Many other surprises await us as we discover the mammalia forms, and in particular, the mammalia, the mammals that gave rise to our contemporary fauna. But that's another story, another period, another journey. See you in the Cretaceous to find out.